Hello, good morning. Today we are talking about the one topic that we call mechanics, and it's a marathon class, and we will take care of the most of the important topic of all mechanics. So we will start from the topic that the motion is straight line, then motion plane, then we will go for another topic that the laws of motion, then we will go for work, energy and power, and the last topic would be rotation and the system of particles. That's the topic we are going to discuss today, and in this topic that is also very important for the NEET point of view, and it is actually heart of the physics. Okay, in the mechanics actually 8 to 10 questions comes almost every year. So 8 to 10 questions, that is a very huge amount of questions out of 45. So it will give you a bunch of different type of models that we, can be asked or that's already asked in the previous years. So we will discuss all the concept and different kind of model in this class. Okay, so please be with me and try to understand what is the meaning of those things. Okay, and different model, try to learn it. Okay, so we are going to start. Don't waste the time. Come to the point. Okay. So very first thing, I am just discussing motion in a straight line. In motion in straight line, there are few points that we are going to discuss. The very first point is the rest and motion. Second point is the distance and displacement. Next point we will discuss the speed and velocity. Next thing we will discuss acceleration. Then we will discuss about motion under gravity. Okay. And there is one more topic in the NCERT when we will see that the topic is actually relative motion, but I will take care relative motion altogether, motion in one straight line and motion in plane altogether. So I am not covering in this part right now. So with the time we will see it. Okay. So these are the five topics are there that we are going to discuss in this first part of the class. Okay. So now I am going to start first with the rest and motion. What is the meaning of rest and motion? If you are thinking about the rest and motion, beta, in that what is the meaning of rest? Rest means if the position of a particle does not change with respect to time and with respect to an observer, that we call it rest. Okay. So if the position of a particle does not change with respect to time and with respect to an observer, that we call rest. If position is changing with respect to time and with respect to an observer, that we call motion. That means the rest, when we are defining, suppose this board I am saying it is rest. Okay, if I say this room is at rest, this camera is at rest, or this fan is at rest, or this studio is at rest. So it depends on me because I am standing right now. So for me it is at rest. If I start moving, for me this whole system would be start moving again. That means it depends on the observer. So if I was at rest, then this whole system was at rest. But if I start moving, definitely it is also start moving with respect to me in the opposite direction. That we are talking about. That means what is the meaning of state rest and motion. One more thing about the rest and motion is that there is no meaning of absolute rest. There is no meaning of absolute motion, beta. When we are talking about absolute rest, means if anyone is seeing in this universe, that body is looking at the only at rest. That means it is not going to change. That we call it absolute rest. For every observer, that body remain at rest. That means that the body that means that the absolute rest. But it is not possible because if anybody you are saying it is absolute rest, I will start moving with respect to that body. So for me that body will be going in the backward direction. Just like if I am sitting in a train. So for me the trees are moving backward direction. The train track is moving backward direction. The ground is moving in backward direction. So it is just with respect to the observer it's happened. So similarly for the motion also there is no absolute motion thing. If you are saying anything is a motion, I will sit on that body only. So with respect to me, that body would be at rest. Just like if you say aeroplane is in motion, so I will sit inside the aeroplane, for me that is at rest only. So it's a very basic thing that we are discussing, that means rest and motion. Now the second term comes to you, that is we call distance and displacement. Then what is the distance and what is the displacement? The actual length of path covered by particle during its motion, that we call it distance. The actual length of path covered by particle, that we call it distance. Suppose A to B you are going. So there can be n number of paths. Suppose I am drawing some path here, that these are some paths. Path number 1, path number 2, path number 3. These are different paths. Okay, and suppose the particle become too much serious, so it can go on this path also. Okay, just like jellyfish. So this is the 1, 2, 3 and 4 path I am just drawing it. So for all these 4 paths, though if I ask you what is the distance, so distance, how to measure? Take one string and put over it like this. So you will get the actual length of this path, that is the distance. If you put over it, that would be this distance, path number 3. If you are putting over the string, you will get this path length of the second, okay, route. So you will get a different distance in each route. This is we are understanding of the particle. But when we are talking about the displacement, displacement is the shortest distance between the shortest length between the initial and final position. The shortest length between A and B, only the path number 3. Path number 3 is the shortest distance. When we are talking about shortest distance, that is the path number 3. So in path number 3, when we are talking, that is the displacement, and other can be distance. So what we are understanding, distance can be, okay, and distance can be, if I am talking about, greater than or equal to magnitude of displacement. Magnitude of displacement, that's the very basic thing that we are discussing here. Okay, that's the very simple thing. I will give you one more example, you will understand. And it can be equal, distance and displacement can be equal only in one case. They can be only equal only in one case, when the particle is moving on a straight line. Particle is moving on a straight line A to B, but without turning back. Without turning back. That means it is not turns. If you are not turning, then it will be what we call the distance is equal to displacement. Even on the straight line, if it turns back, then also suppose it turns from here and reaches to the C, so definitely the distance and displacement are not equal. So we have to understand very clearly that distance and displacement would be equal only and only when the particle is moving on a straight line and they remain on the same direction, that they are not changing their direction, then only their distance and displacement are equal. Now come to the next point. When we are talking about distance, distance is scalar quantity, displacement is a vector quantity, and they are measured in the meter. The SI unit is equal to meter we are talking about. Now come to the next point that we are discussing, that the speed and velocity. When we are talking about the speed, what we are discussing, speed is equal to, very simple thing, that the speed is equal to what, beta? We can discuss the distance covered per unit time or time interval. So we are discussing very simple, the distance covered divided by time interval, that we call it speed. So this is distance, and we are talking about when distance, so distance is a scalar quantity and displacement is a vector quantity. Similarly, the speed is a scalar quantity. Distance is always positive. Why it is positive? Because when particle is moving A to B, that means that is the only length we are measuring, and length cannot be negative. We cannot say from Vijayawada to Hyderabad, that distance can be negative, or Vijayawada to we can say Delhi, or Delhi to Bombay, this cannot be negative. This distance is always positive. So distance is positive, that means speed is also positive. Speed cannot be negative. So try to understand it. Now, but if we are talking about the displacement, displacement can be positive, it can be negative, it can be zero. So all is possible, that we have to understand very clearly. When we are talking about the speed means distance covered per unit time interval. So this is a scalar quantity, we can say this is scalar quantity. When we are talking about its SI unit, that is equal to meter per second, we are discussing very simple thing, that is the meter per second. But when we are talking about the velocity, velocity means that is equal to displacement covered upon time interval. So we can discuss the displacement covered upon time interval that we call velocity. It would be what beta? Scalar or vector? Definitely it is a vector quantity because displacement is a vector quantity. When displacement is vector, the velocity is also vector. Displacement can be positive, displacement can be negative, displacement can be zero. Similarly, velocity can be positive, can be negative, can be zero. So it all possible. It's the vector quantity, and its SI unit is also meter per second. If you are writing dimension you can say actually here LT minus 1. That's the very simple. Similarly, here also dimension you can say that is equal to LT minus 1. It's a simple thing. Now come to the next point. What we are discussing here, beta. After speed, this is speed and velocity. Similarly, the speed. If I say speed would be also greater than or equal to the magnitude of the velocity. That should be very clear to you, because the distance is greater than the displacement. Similarly, the speed can also greater than also velocity, but it can be equal only in one condition: the particle is moving on straight line and in same direction without turning back. So without changing direction, that we can discuss. Now there are two more terms we are going to discuss. Very simple. First is the uniform and non-uniform. Okay, when I am talking about uniform and when you are talking about the non-uniform, what is the meaning? Uniform means beta, the uniform speed means actually the particle is covering equal distance in equal interval of time. Suppose I am taking a bike and my bike is moving, okay, and the constant speed of 60 km per hour. So 60 km per hour it is moving. That means that is the constant value. It is not going to change. So that we call it uniform speed, okay, constant speed, it is not changing. That means equal distance I am covering 60 km in every 1 hour, every 60 km I am covering in every 1 hour, that we call it uniform. If it is not, I am not covering like that. Suppose 1 hour, first 1 hour I am covering 60 km, next 1 hour I am covering 50 km, next 1 hour I am covering 70 km. This is not uniform. That we call non-uniform speed. Understanding? So unequal distance covered by particle in equal interval of time, that we call it non-uniform. Similarly, we can discuss the velocity also. So uniform velocity. Uniform velocity, when we are talking, so try to understand first velocity. I told you velocity is the vector quantity. Vector quantity means it is having magnitude, it is having direction. That means its direction also should be there. So magnitude is also there, direction is also there. So when both are in same, both are constant, direction also not changing, magnitude also not changing, then only I can say it is a uniform. If any one of them is changing, then it is a non-uniform. Very simple thing, we can say that is a non-uniform thing. Clear? Now come to the point. When we are saying it is non-uniform, suppose the particle is moving in a circle, the direction continuously changing. Particle is the pendulum is there, so that is also non-uniform. If Earth is rotating about the sun, that is the elliptical part, that is also non-uniform speed, because non-uniform velocity, because it's a direction continuously changing, that we have to understand it. Okay, projectile motion, so it is changing in a parabolic path, that is also direction is continuously changing, speed also changing, we will learn with the time. Okay, now try to understand. Similarly, non-uniform means that the direction is changing or magnitude changing or both is changing, then we call non-uniform velocity. Clear? What is the uniform, what is non-uniform? Clear? Now come to the next point, that is the important one, that we are talking about the average and instantaneous. When I am talking about average, so we have to learn very clearly what is the meaning of average. So if I say average speed means total distance covered by particle, total distance covered by particle in total time interval, that we call average speed. Okay. Similarly, if I say average velocity, that means the net displacement covered by particle in total time interval, that we call it net average velocity. I am repeating again, average speed. If I am saying average speed, beta, it's the average speed. If I say average speed, that is equal to total distance covered divided by total time interval. Total time interval, that we call it average speed. It is also a scalar quantity, definitely it is a scalar. Its SI unit is also meter per second, it is nothing new, and it is always positive, no doubt about it. It cannot be negative, that we have to clear about it. Now if I define the similarly the one more thing, average velocity that you have to clear about, average velocity beta. So that would be net displacement upon total time interval. That I am talking about the average velocity. So average velocity, that is the net displacement, and now displacement we already know it can be positive, it can be negative. So both is possible. So that's why we can say average velocity can also be positive, it can be negative, it can be zero also. So we can say it is also vector quantity first thing. SI unit is also meter per second. It can be positive, can be negative, can be zero. So all three is possible. That's very clear to you, that we call average speed and average velocity. Now come to the next point when we are talking about, that is equal to instantaneous speed. What is the meaning of instantaneous? Suppose I am driving a bike, or I am riding in a bike, and bike is moving. Suppose at this instant, right now, if I am talking about the time, if you see the time is the right now, that is the 9:21. So at 9:21, I am writing it 9:21 AM. My speed is suppose 60 km per hour, and 9:22 AM, that my speed is suppose 62 km per hour. If I say the 9:23 AM, my speed is suppose 70 km per hour. So I am just telling you at different instant my speed. This speed we call it what beta? Instantaneous. That at speed of a particle at a particular instant, that we call instantaneous speed. Okay, that instantaneous speed we are talking about, so it is defined. Similarly, the instantaneous velocity. Instantaneous velocity is nothing else. Instantaneous speed with direction. Instantaneous speed with direction known as instantaneous velocity. That means instantaneous speed and instantaneous velocity, their magnitude always equal. Till now I was saying ki average velocity and average speed may be equal, may not be equal, depend on the what is the path. But instantaneous speed and instantaneous velocity is always equal. That we have to learn very clearly. It is always equal. They cannot be different value. That we have to clear about it. So this is the instantaneous speed, instantaneous velocity. Now come to the next point that we are going to discuss, that we call it acceleration. So when I am talking about beta acceleration, that we have to learn first. What is acceleration? It's the very simple thing, rate of change of velocity with respect to time. Rate of change of velocity with respect to time, that we call it acceleration. It's the what beta? It's the vector quantity. SI unit. What is SI unit? SI unit is a meter per second square. If I write the dimension, that would be LT minus 2, that we can write it. Very simple thing. It's also vector quantity. It depends on the velocity. It depends on the change in velocity. That means it can be positive, it can be negative, it can be zero. That's why we define some term that sometimes we call acceleration term. I will define each and every term. Acceleration, sometimes we call deceleration. Sometimes we call it retardation. Sometimes we call positive acceleration. Sometimes we call negative acceleration. We use these terms. That should be very clear to you. And there are some differences are there between these terms that you have to learn it. When we say acceleration means if the speed of the particle is actually increasing with the time. That means velocity is increasing, magnitude of velocity is increasing with the time, that we call it acceleration. Okay. But when you go for deceleration, that means it is a decreasing, speed is decreasing. If speed is decreasing, so that term sometimes we call retardation also. So they are same terms actually. So deceleration means I am retarding my speed, okay, or decelerating my speed. Okay. Suppose particle is moving at 60 km per hour. I am putting a brake, now it is decreasing to the 40 km per hour or 30 km, or I am going to stop also. So that is we call deceleration or retardation. When we say positive acceleration or when we call negative acceleration, it will totally different from acceleration and retardation. Try to understand. There is some confusion is there always. Some student assume the positive acceleration. When we say the positive acceleration, so they assume positive acceleration means speed will increase. Not necessary. Suppose particle is moving in positive direction only. Suppose I am taking this as a positive direction beta and it is a negative direction. Okay. So in a positive direction, particle is also moving, velocity in a positive direction. If acceleration is in a positive direction, then what will happen? The speed will increase with the time. But if particle, this was the first case. If I say second case, if particle is moving in negative direction, but acceleration is positive means positive direction, then what will happen? Its speed will decrease with the time. So if the question is asked, very simple, very conceptual question comes here, okay, if acceleration is negative, that means what will happen? Speed will decrease always? No, it depends. First tell me where the object is moving. Okay. Second, if acceleration is positive, that means always speed will increase. Answer is no. First tell me where the particle is moving. If particle is moving also positive direction, then it will increase. If particle is moving in negative direction, then it will decrease. That you have to clearly understand that part. So I am repeating first thing. If velocity and acceleration both are in same direction, then magnitude is going to increase. If both are in opposite direction, then magnitude is going to decrease of the velocity. That should be very, very clear to you. So similarly, when we say negative acceleration, that means it is just telling you the direction of what? Acceleration. Now there's some conceptual question I am discussing one by one that sometimes comes to your mind. The very first thing, if the velocity and displacement, their action would be always same or they can be different. The very first statement I am giving you, that type of question comes to you in the paper, कि velocity and acceleration that always in the same direction. So what is the answer? Correct. It is a correct statement because velocity and wherever the particle is moving, the same direction displacement will occur. So velocity and displacement always in the same direction. First thing. Second question comes to you. When I am talking about, this is instantaneous, that remember what I am talking about, instantaneous word. Now come to the second point. The acceleration and velocity are always in the same direction. The answer is no. It is not required. It can be different direction. There's different examples of that. I can show you the examples. Example, suppose there is a particle is moving on a projectile motion. It is moving like this. So velocity here and acceleration is downward. That the acceleration due to gravity. So they are not in same direction. So it can be indifferent. Some particle is moving in a circle. So you can see the velocity is here, beta, and acceleration in this direction. So you can see there is a perpendicular. So that is not actually in same direction. So they can be in different direction. It is also possible, not necessary that they are in same direction. So acceleration and velocity can be in different direction. But now there some things are there that you have to remember. I will discuss. Very simple. If velocity is parallel to the acceleration, they are in same direction. Either I can say both are in same direction or anti-parallel. In both cases, the straight line, it would be the path. A straight line path is there. Very first thing. Second question is there, okay, if I say here the velocity is always perpendicular to the acceleration, always. If I say it is always perpendicular, then it would be circle. Okay, particle would be in circle. That means acceleration and velocity always in perpendicular, then it would be circle. The third case, if I say the angle between velocity and acceleration is theta, and theta can be any value 0 degree to 180 degree, any value, it is changing, it is also changing, that we call it parabolic path. Parabolic path, that should be clear to you. So parabolic path means projectile motion, it's the parabola beta. So here you can see this angle is every point changing, it is not at the highest point, it is the perpendicular also. So acceleration and velocity is changing. Okay, it's the changing, it's the v2 prime, I am just saying this is changing. So this is the parabola. Here you will see they are perpendicular, any point of time you will see this is the perpendicular. Okay, this velocity and the centripetal acceleration both are perpendicular. So it is a circle. So this is a few things that you have to understand. One more question comes to you, okay, acceleration is suppose decreasing with the time. If acceleration is decreasing with the time, then what will happen? The speed will increase or decrease? The answer is it will increase. It will increase. Suppose I am giving you example. Okay, suppose I am riding on a bike and bike acceleration right now is suppose 10 meter per second square. 10 meter per second. So my speed is increasing every second 10 meter per second. Every second is increasing by 10 meter per second. Suppose initial speed was 0, so after 1 second it would be 10 meter per second. After 2 seconds it would be 20 meter per second. So every second it is increasing by 10 meter per second. This meaning is this. Now second, if next second my acceleration decreases, it becomes 8 meter per second square. So in first second my speed was increased by 10 meter per second. In next second also it will increase by but 8 meter per second, not 10. So that would be 18. Still my speed is increasing. Try to understand. Suppose my acceleration further decreases, it becomes 6 meter per second square. That means still my speed is increasing by 6 meter per second in next second. So total become 18 plus 6, that is equal to 24 meter per second. That means speed also increasing with the time. That should be very clear to you. Now one more question is there. If particle is having acceleration is equal to 0, then velocity must be 0. Not required. Particle is moving in a uniform path, straight line with a uniform speed, not required any acceleration, it can move, no problem. If I say if particle is having 0 velocity at an instant, then its acceleration also 0. Not necessary. If I take one particle and I am throwing it upward, and at the highest point, if you see, it will come, and at the highest point my velocity would be 0. So but acceleration is not 0. But that at particular instant, what is happening? Velocity is equal to 0, but acceleration is not 0. So that we call it. It is also possible that particle is having at a particular instant velocity 0, but acceleration is not equal to 0. Possible thing that you have to clear about it. So these are few basic things that I have discussed about the first. We can say what is the distance, what is the displacement, what is the speed, what is the velocity, what is the acceleration. Basics. Now we have to understand the basics. Some questions I will discuss few questions that you will understand it. Okay. Now try to understand. Suppose related to displacement I am discussing very basic questions. For very first question, suppose particle is moving on a circle, so this semicircular path. So A to B it is moving, and if I say this path length, this radius is equal to 10 meter, and a particle is moving A to B like this on a semicircular path. So question is that what is the distance covered? What is distance? First thing, what is displacement? Very basic question I am asking it. What is displacement? Can we discuss? Definitely we can discuss. So what is distance? Distance would be this actual length of path. So that would be pi r, semicircle, that is equal to pi into r beta. So what is the r? So r is 10 meter, and pi we can multiply, so pi into 10 meter, that's the answer. You can solve further also. This is beta 3.14 into 10, that would be 31.4 meter. That's the simple thing. Now come to the displacement part. Displacement is the shortest length between initial and final position. That means here to here we can see directly. So that length would be equal to, this is also 10 meter, it is also 10 meter, total become 2 into 10 meter, or 2r we can say. So 2r we can say, or equal to diameter. So 2 into 10 that meter, or we can say 20 meter. So you can see very clearly that distance and displacement are not equal here. Okay, that we are discussing. One type of problem I have discussed. Now suppose example 2 I am taking related to displacement, and suppose one particle is there, it's the east direction, it is the north direction. I am saying suppose this is west and this is south. There is one particle is there, and it is moving first 10 meter along east, and then 20 meter okay towards north, and now he is taking right turn, and it reaches further 10 meter, it is moving further 10 meter, and it is reaching to its final destination. It starts from A and it reaches final to the B. That's the question. Now they are asking their question what is the distance covered and what is the displacement of the particle. That also second type of problem comes to you. I am discussing that part. Try to understand. So how to solve? If you join this point, initial position to this final position, then you will understand that this is the displacement. But I am talking about a suppose distance. So what is distance beta? So distance is equal to 10, 20 plus 10. So 10 meter plus 20 meter plus 10 meter, that is equal to 40 meter. Very basic. If I am discussing about the displacement, what is the value of displacement? So we have to understand how to calculate the displacement, means initial position to final position. I am just joining it. We have to calculate. So very simple thing, please understand. here to here, that distance first we have to cover, this distance we have to cover, and then we can find this hypotenuse, because this is a right angle triangle. So this is 10, this is 10, this total become 20 meter beta. It's a 20 meter, 10 and 10, 20, and this is already 20 meter. So this is 20, it is 20, that we can find. Now displacement, that would be under root of 20 whole square plus 20 whole square. So that would be actually 20 root 2 meter. It's a very basic thing. Clear? Now similarly, if I ask you its direction also, because without direction this everything would be wrong. Try to understand. So we have to calculate this angle also, beta theta. So how to calculate that tan theta? So tan theta would be perpendicular upon base. Perpendicular upon base. What is perpendicular? That would be 20 divided by, further this is 20, so that would be equal to 1. That means theta equal to 45 degree. That means this is a theta equal to 45. So this direction we call northeast direction. Northeast direction displacement. So displacement is in northeast direction, that we are talking about the displacement. So there are few basic type of question that I have discussed here. Okay, what is the meaning of displacement? How to calculate it? Understood? Now come to the next point. I am discussing some question related to the speed and velocity also. Come to the speed and velocity. That's a very basic question I am discussing here. Okay, suppose one particle is moving here to here, A to B, okay, and it covers this distance, it travels for equal distances, okay, it travels for equal time interval with the speed of v1 and this is speed of v2. This time interval is t, this is also t, it is the speed v1 and this speed is v2. Now they are asking find the average speed. Average speed. By the way, average speed and average velocity both would be same because it is moving in a straight line. Try to understand. Now average speed we are calculating. So average speed is equal to total distance. Okay, total distance divided by total time. That we are discussing here. So what is total distance? Total distance would be here to here. We have to calculate first. So how to calculate? Suppose I am assuming this distance here to here beta x1 and I am assuming this distance is x2. So first we have to calculate x1 and x2. So what is the distance? Distance is equal to speed into time. We can put it. So that would be x1 plus x2 divided by time interval is t plus t. So what is x1? You can say speed into time, that means v1 into t plus this is v2 into t, okay, divide by 2t. T can be cancelled, that would be v1 plus v2 divided by 2. That we can say average speed here. We can discuss. Very simple. Now similarly, this same question already P by Q question. Similar question I can discuss here. Okay, suppose the particle is moving from A to B beta, and it is traveling for equal distance. It is traveling for equal distance. Suppose this is the x distance and it is also x distance, and with the speed of v1 and v2. Suppose this time interval was t1 and this time interval was t2. The very first question comes to you. What is the value of this average speed? What is the value of average speed? By the way, average speed and average velocity both would be same because direction is same, it is moving on a straight line. So if I say here also average speed, so average speed would be again total distance upon total time interval. So total distance is x plus x, this is also x, it is also x, divide by time interval, this is I am assuming t1, this time interval I am assuming t2, so this is t1 and t2. So but t1, t2 are not given, we have to calculate them. So how to calculate? Directly you can say it's a 2x divide by, what a time? Distance upon speed. What a time? Distance upon speed. That means x by v1 we can say, and similarly x by v2 we can discuss. That we call it average speed. Okay, it is the average speed. So average speed would be beta from here, x can be taken common, so 2 divided by 1 by v1 plus 1 by v2. Okay, we can discuss and we can say this is 2 and this would be beta v1 plus v2 divide by v1 into v2, and we can solve little further. So this would be 2 into v1 and v2 divide by v1 plus v2. Very basic question I am just discussing, that we call it average speed. Okay, that I am discussing, that the average speed. So how to calculate average speed we can discuss here. So average velocity, that's the very basic thing. Now some more question I am just discussing that you have to understand. Okay, now try to understand. Suppose one particle is there It is moving on a circle. I'm just taking, don't confuse with the particle in a straight line, so you are telling why you are taking circle. So you already know the basics. So I'm just discussing this. Try to understand. So I'm just saying here particle. Suppose this particle was initially at A and this particle at B. It's a very important question that you have to learn it. And suppose this angle is theta and this radius I'm assuming R. And here speed is V. It is also V because we are assuming that the constant speed is moving. So question is, what is the change in speed or what is the average acceleration? That the question comes to you, that we have to understand. And they can ask one more question, what is the displacement, what is the distance covered. So if I ask you what is the distance covered, first thing, so distance would be how much beta? Distance would be here A to B, that is the path. So we directly can say that is equal to theta into R. How I am writing? You already know, because the arc length, theta is equal to arc length, that means AB arc length, and upon this radius that we call R, that means arc length would be equal to how much beta? That is equal to theta into R. We can discuss. So this is theta into R. That is a very simple thing that we can say distance. Now second question comes to you, displacement. Okay, that is the displacement I am discussing here beta. So what is displacement? We have to discuss. So displacement would be when you are joining this point A to B directly with the straight line. This is displacement. So to calculate this length, we have to put perpendicular from here. That would be calculation for this. I am just discussing. Please understand here. This angle would be theta by 2. This angle is 90. This is R. This is theta by 2. So along theta we call cos. Perpendicular to theta that we call sine. This is R cos theta by 2. This is R sin theta by 2. We require this distance, that means R sin theta by 2. Similarly, this is also same, R sin theta by 2. That means total distance become AB is equal to become beta 2R sin theta by 2. 2R sin theta by 2, that we call it displacement. So what is distance, what is displacement? It should be very, very clear to you. Nothing is difficult in this. Clear? Now come to the one more thing. What is the actually change in velocity? So when we are talking about change in velocity, for that we require some vectors. So vectors basic understanding we already have. So we can understand, we can discuss here beta, and we can put it. So this is a very basic. Suppose I am saying this is x-axis beta, this is y-axis, and I am putting here first thing that initial velocity was in this direction. This was the v, and after some time if you are seeing this is the velocity, okay, and this is v. Okay, now try to understand, this angle was theta. So definitely if I put this angle, this is theta beta, this would be theta. That means with the normal also this is theta. So I can put this angle is theta. There will be two components, this is v cos sin theta and this component would be v cos theta. Okay, so we can say v initial is equal to sir v j cap and v final would be how much? That would be minus v sin theta I cap plus this component would be v cos theta j cap. It's the v final. We know v initial, we know v final. We have to calculate the change in velocity. That would be v final minus v initial. So v final minus v initial, if you are going to do, that value would be minus of v sin theta I cap plus v cos theta j cap minus that would be v j cap, or we can say minus of v sin theta I cap, okay, plus v cos theta minus v j cap. It's a very simple that we call delta v, okay, that we can write it in the vector form. But more than that, it is one required form is what beta? Scalar form. What is the magnitude that we are going to discuss here? Try to understand. So how to discuss? That is the magnitude I am just telling you, delta v magnitude, that would be under root of what value beta? That would be minus v sin theta whole square plus v cos theta minus v whole square. So from here v I can take outside, that would be root, it would be sin square theta plus this would be cos square theta plus 1 minus 2 cos theta, that I am writing it very simple. Now you know the sin square theta plus cos square theta, that is equal to 1, 1 plus 1, that becomes 2. So 2 you can say here v root 2 plus minus 2 cos theta I can write this is also v into under root 2 into 1 minus cos theta. 1 minus cos theta can be written as that is equal to 2 cos square theta by 2. 2 is into sin square theta by 2 that we can discuss. So v into 2 into 2 into sin square theta by 2. That's the very simple, that's the half angle formula for cos. So we are putting it from here, this becomes 2v into sin theta by 2 that we are going to discuss, that is equal to change in velocity magnitude. It's also important thing that we are going to discuss what is the meaning of this. Now second question comes to you ki what is the average acceleration? So when we are talking about average acceleration, what is the average acceleration? Average acceleration is equal to change in velocity divided by time interval. The average acceleration divided by time interval, that we have to remember directly this result, directly you can remember result, and divide by time. Time would be how much? So we have covered the theta angle, and that means theta r distance with the speed of v. So I can say very simple, what the time interval delta t. Delta t is equal to how much, beta? So you will say theta into r divided by v. This is time interval. So delta v we already know, we can put that value, 2v into sin theta by 2 divide by theta into r upon v. So this become how much, beta? I am just writing it, that average acceleration is equal to 2v square by r into sine of theta by 2 upon theta, or better option is to write it average acceleration is equal to v square by r into sine theta by 2 upon theta by 2. It's a very standard result that you have to learn it. Okay, that this is the actually basic of we can say the centripetal acceleration, because from here only when we say when we are putting a special case here, beta, the special case if theta by 2 is a small value. If you put it, it's a small value. Okay, I'm just putting it, that's the small value, beta. It's a small angle. So then what will happen? Sin theta by 2 approximately equal to theta by 2. If they are approximately equal, they will be cancelled out. So this average acceleration become what, beta? V square by r, and that is nothing else, we call it centripetal acceleration. So it's the actual derivation of the centripetal acceleration also, and it's the asked in the paper also, very basic. You find the distance, find the displacement, what is the change in the speed. So change in speed would be 0, change in velocity 2v sin theta by 2. Directly you can remember this result. Similarly average acceleration, that is also directly you can remember. So that's the one lengthy question I have taken, so that you can understand that type of question also we can discuss in the paper, we can calculate in the paper. That's the very basic thing. Now I am taking you related to some question based upon the actually equations. So now come to the point, we are going to equations, that equation of motion we are talking about. Equations of motion. When I am talking about equation of motion, so you already know first equation, that is equal to v equal to u plus at. Second equation I am talking about, that is equal to x equal to ut plus half at square. Third equation is equal to v square is equal to u square plus 2ax. Okay, so v equal to u plus at, x equal to ut plus half at square, v square is equal to u square plus 2x. These are three standard equations. I am just telling you the each term. What is v? Final velocity. U is the initial velocity. What is the a? Acceleration. T is what? Time interval. I am repeating again. V is the final velocity, u is the initial velocity, a is the time acceleration, and t is the time interval. What is x? X is the displacement. Many students makes a doubt here, what is the x? This is distance or displacement. So it is a very clear, that should be displacement. This is not actually distance. So displacement, u is the initial velocity. Again we know the t, what has been a, that we all understand. Similarly here also there is a final velocity, initial velocity, acceleration, and displacement, not distance. One more formula we write it, that is equal to Sn is equal to u plus a by 2 into 2n minus 1. That's the very standard result that we are using. This is what, beta, Sn means the displacement covered by particle in nth second. The displacement covered by particle in nth second, that we call it Sn. U is the initial velocity, a is the acceleration, and n is the that time, whatever second. Suppose you are saying fifth second, what are the displacement covered. So based upon this, already there are some questions are there. I'll discuss one question. you will understand. Very basic question, please understand. Example, I am just telling you, okay, find the ratio of Sn by Sn, okay, I can say plus 1, Sn plus 1. This is the one standard question is there, NEET question is there, you can find. So what is the Sn by Sn plus 1, how to calculate, and it is given to you, particle start from rest. You have to calculate if initial velocity given to you 0. So what to write, you will say Sn upon Sn plus 1, I am just writing it. So you will say, so u is 0, yes, this is a by 2, this is 2n minus 1. Similarly, this is also a by 2, and this would be 2 into n plus 1 beta minus 1. We can write like this. Clear? A by 2 cancel. So from here you can say Sn divided by Sn plus 1 is equal to, this would be 2n minus 1 beta, and this would be 2n plus 1, that the ratio. It's the one question, that is already P by Q that you have to understand. I'll discuss some more problem. Just example 2, suppose they are asking it, okay, particle start from here A to B, they are asking it A to B, if initial velocity was u, final velocity is v, and they are saying here ki find the very simple ki midpoint. Suppose this distance is here x this side, and this distance is also x. So this is the midpoint, that we call it P point. Suppose I am saying it is the P point. At P point find the velocity. So I am saying this is the midpoint velocity. The midpoint velocity they are asking it. What is that value? The midpoint velocity we are asking, initial velocity u, final velocity is v. The question is that what is the midpoint velocity? So how to calculate those things? So midpoint velocity, very simple. The first you have to calculate what beta? Acceleration here, and from that acceleration I can find this midpoint velocity. So I am just putting it. So you will apply the third equation 2 times. So you will say v square is equal to u square plus 2x. This is the third equation. Final velocity is v. You will say v square, initial u square plus 2a, and this total distance was 2x. I am assuming it. Clear? So from here you can say v square minus u square is equal to 4ax. So if I ask you what is the ax value, you can say v square minus u square divided by 4 is equal to a into x value. So wherever required I can put it. Now similarly again I am writing the third equation. So because between a and p I am applying. Now between a and p point you will say again third equation beta. Again third equation, you can say the v square is equal to again u square plus 2x. Okay, so now here you will see here is again midpoint velocity that we have to calculate, midpoint, and square is equal to initial is u square plus 2. What is the acceleration? The acceleration a into x, complete value, ax value we already know, this value. So you will put it v square minus u square divided by 4. So from here this becomes 2 actually. So this is the midpoint velocity square is equal to, you will take LCM 2u square plus v square minus u square. So this can be written as v square plus u square divided by 2. Okay, and that would be root, that would be midpoint velocity. Very basic, very standard question. Sometimes this question comes to you, we can discuss that question also. Clear? That's the very standard problem I am just discussing. Okay, one more very standard question is there that you have to learn it, you have to understand it, that we call train problem. What is the meaning of train problem? If suppose one train is there, okay, and it start from one station and reaches to the second station. So start from one station reaching to the second station, understanding? So initial velocity also 0, final velocity also 0. First it accelerate with some acceleration, suppose alpha, and after that after some time it start decelerating with the some acceleration that we call it minus beta. Start decelerating with some deceleration, that is the minus beta, and stops at station B. To start from A and reaching to the B, it is the happening. Now they are asking some questions. There are actually 4 standard problem comes based upon this. So 4 standard problems are there that we have to understand it very clearly. Okay, so I am just discussing one by one, just try to understand it. Suppose you are starting from this point A and this you are reaching to the B, okay, and this is midpoint, and this here alpha, this is given to you, and this is the what beta, minus beta, retardation, that you have to understand it. okay, and here initial velocity is 0 and the final velocity also 0. Now you have to understand very clearly few things. I am just writing it. Because initial velocity 0, this is acceleration, so definitely speed is increasing. When it reaches some point P, definitely it would be maximum velocity, and again it start decreasing and final becomes 0. This is the maximum velocity that we have to calculate it. So what is the maximum velocity? They are asking it, very basic question. So to calculate this part, I am just telling you a few things. You can draw the graph and you can understand the graph things. Suppose this is a V versus T graph, I am drawing it. So V versus T graph, that we know the slope gives you the what beta? Acceleration, and area under the curve gives you displacement. Try to understand. So if I am drawing this graph, you will see here that the first it is the alpha acceleration, and then it is the beta, and it finally becomes 0. So this is the maximum velocity it is attaining, that is the V max. Okay, this is the first, this P point was there, and this time interval was T1. Suppose I am assuming this is T1, and this time interval I am saying T2. This is T2. That you have to understand it. Clear? So very first thing we have to calculate what beta? V max. So this was the alpha and it is the beta. So we have to calculate what V max. So how to calculate V max? So very standard question is there. Suppose here the time intervals are given to you, directly you can calculate. If time interval is not given, suppose total time is given, then also you can calculate. Suppose I am saying this total time is given to you, then also you can calculate. So you will say suppose this is T and this total time interval is capital T. So T2 would be T minus capital T minus T1. You can use it. So suppose I am saying V max beta. So V max is equal to how much value? So alpha it is given to you, because I can write like this also beta. Alpha is equal to V max upon T1. So V max upon T1. One thing, T1, small T1, we can write it. Similarly, beta also I can write. So from here that is equal to V max divided by T2, or I can say V max divided by capital T minus T1. I can write, if capital this small T1 is given to you. So from here we can write very simple, T1 is equal to V max divided by alpha. I can write it. It's the very basic thing. And similarly from here alpha value we know, and we can put it here alpha and we can get the value. So what you can say beta? You can say sir beta is equal to beta into 2. Beta into capital T minus T1 is equal to, we can say V max. I am just putting the value. This is beta, it is the capital T minus T1 value is equal to V max by alpha, okay, is equal to V max. So just I am multiplying Bt minus beta by alpha into V max is equal to V max. I am taking V max this side. It's the beta into T is equal to beta by alpha plus 1 into V max. I am writing little bit further. It is a beta into T beta. It is the alpha plus beta divided by alpha into V max. So from here you can say V max is equal to alpha into beta by alpha plus beta, okay, into capital T, that we can use it. That's the simple standard result that we are using it. Okay, so this is the V max. So sometimes they ask it what is the V max, so we can calculate the V max value also. If we know the V max, definitely we can tell the T1 also. If I ask you what is T1, so T1 you can tell it. Okay, sir, T1 is equal to what beta? V max by alpha. So V max by alpha, if I am putting it, that is equal to how much beta? So you can say directly beta upon alpha plus beta into capital T. And similarly T2 you will calculate, that also you can do it. What is that value beta? T2 is equal to V max by beta. That value is equal to alpha divided by alpha plus beta into T. So these are basic type of question comes in paper, we can discuss it. If we know the total time interval, we can calculate the distance also. What is total distance covered here to here? Okay, so total distance also we can calculate. What is total distance? So for that total distance you can use it in very basic term. Okay, what are the area under the curve? Because we know the total time interval, V max we already know, so we can find area under the curve. So total distance would be how much beta? 1 by 2 base into height. What is the base? That is equal to T into V max. Vmax already we have just calculated that value, we can put it. So d is equal to how much? 1 by 2 into t, that would be alpha into beta divided by alpha plus beta into t. Clear? So from here this become what beta? Alpha beta divided by alpha plus beta, okay, into 1 by 2 into t square, that is equal to d. So this is a basic type of problem that we can discuss, that related to the train problem. Now we are going to discuss next thing, that is equal to, we have to understand related to the motion under gravity. Now I am taking to the motion under gravity. Motion under gravity. When I am saying motion under gravity, first thing you have to understand what is the acceleration. So acceleration is equal to g value beta, and this value g value is a 9.8 meter per second square, and it's approximately 10 meter per second square that we are writing it, and sometimes we are using approximately equal to also pi square meter per second square, approximate value, not equal to, that you have to understand it. This is a very simple thing, motion under gravity. And first thing you have to understand what is the sign convention. Sign convention, we are saying it's the horizontal direction beta, okay, horizontal, and this is the vertical direction, okay. Upward direction I will take positive, and this downward direction we will take negative. Upward direction we will take positive, downward direction we will take negative, that we have to understand. Either it is displacement or velocity or acceleration, anything we will take negative, okay. Upward direction, either it is displacement or velocity or acceleration, we will take positive, that we have to understand. Clear? Now acceleration due to gravity always vertically downward, that means I will always take that is equal to minus g. Minus g means it is the downward direction only, because always downward, that you have to understand. So from that thing we can write very simple, this equations of motion. First equation was I am writing that is equal to v equal to u plus at. Second equation I was writing x equal to ut plus half at square. Similarly, third equation I was writing that is equal to v square is equal to u square plus 2x. These equations can be written, rewrite like this, that is equal to v equal to u minus gt. Similarly, this is x equal to ut minus half gt square, or you can say v square is equal to u square minus 2gx. I can write it. These are few basic equations that we are using in the motion under gravity, we have to understand. Now I am discussing few cases. Case number 1, suppose you are throwing a one ball from the bottom, from the ground, and it is moving upward direction and it is returning back. I am throwing a ball vertically upward, it is coming back. So when it is going upward direction beta and coming back, the question is that what is the maximum height attained, what is the time of ascent, what is the time of descent, what is the velocity with which it will return back. So suppose initial speed was given to you u, the question is what is the maximum height it is attaining, that is the very first thing, that is the maximum height. And when it is returning, what is the velocity that they are asking it, okay, what is time of ascent, what is time of descent, so what is time of flight, this is the question. That is the very first question they are asking it. So there are two motions are there, first is ascending motion, second is descending motion. So I am discussing one by one, so you have to understand very clearly. Ascending motion beta, ascending motion. When I am saying ascending motion, so in ascending motion you will say directly that the particle is moving from bottom and reaching to the topmost point, this velocity is 0, initial was u, okay. So we have to calculate height and time of ascent. There are two things only we have to calculate. To put it, so very simple, you will say v equal to u minus gt. So final velocity is 0, initial was u, positive, upward action. This is g into time of ascent. So what is time of ascent become? U by g. Very simple. Simple result, we have to remember, it is useful. Now second result comes to you, what is the height? What is the height attained? If I am talking about the height, so directly you will apply the third equation also, you can apply second equation also. I am applying third equation, v square is equal to u square minus 2gx. Final velocity 0, initial is u square minus 2g. Height attained is suppose h, I am taking h, I am taking this side, that would be 2gh is equal to u square, that means h is equal to u square by 2g. That I am writing it very clearly, we can remember this result, okay. This is ascending motion. Similarly, we can discuss the one more thing that we call descending motion beta. What is the meaning of descending motion? That you have to learn it. Suppose a particle is now coming from the topmost point and is returning back. This velocity would be initial velocity 0. Now finally it is reaching, suppose v prime, we have to calculate v prime. This height already we know that is equal to h. So how to calculate that part? You have to put it very simple. Third equation you can put it. So v square is equal to u square minus 2g x, actually I am putting. Final velocity is v prime square. Initial was 0 minus 2g. Now what is displacement? Displacement negative value, that is the h. So minus h we will put, minus h value is u square upon 2g. I am putting it directly. So 2g cancel, this minus minus become plus. So v prime square is equal to u square, that means v prime is equal to plus minus u. There two value would be there. Definitely I will use minus because it's the downward direction. So what is the v prime? V prime is equal to minus u. That means speed is part same. Initial speed is u, then final speed also u, but directions is opposite. Directions is opposite, that you have to learn it. Now come to the next point, beta. We have to understand here, that is the what is the time of descent. When I am talking about time of descent, again you can use either first equation or second equation. I am using first equation, v equal to u plus u minus gt. You can write it, u minus gt. Final velocity v prime we already know, and this is the initial velocity 0 minus g into time of descent. What is v prime value, by the way? We have already calculated, the minus u. Minus minus cancel, so time of descent is equal to u by g. That is equal to again time of ascent. So time of ascent is equal to time of descent. It happens only when it is a what? There is no air friction. If air friction is there, definitely there would be different values of time of ascent and time of descent. They are equal. Only in air friction is not present. Try to understand. Up to here I think you are understanding. Very good morning. There are few students saying I am sorry, I am a little bit focusing more on board and I am not replying it. Hello beta. Okay, my name is Hari Mohan Singh, Ramesh. Okay, and hi Arshita, and any problem is there, you can discuss, you can ask in the, now I will try little more on chat box. You can put your queries there, I can discuss it. Okay, I'm sorry, I was focusing more on board so that I can give you the more and more content, and you can put some comment, that would be better. Okay, Samir, yes, Hari Mohan sir, good morning, very good morning. Okay, now come to the point, that is the time of ascent and time of descent is the same, and if I talk about the total time of flight is equal to Ta plus Td. If you add both of them, that would be equal to 2u by g. That's the, we call it, very simple result that we are using in the motion under gravity equations. Okay, we are just dealing some more problem. I will just discuss with you motion under gravity. Suppose I will take one tower, and from this tower I am just one stone I am drop, I can say first I am throwing vertically upward, and this speed is suppose 10 meter per second. Okay, and this is already here, if I am talking about 75 meter height of the tower. Now question is that how much time it will take to return the ground, how much time it will take, and with what speed it will take. So we already know that this will go upward and like this, and it will return to the ground. So what is the time of ascent and what is the time of descent, we have to understand. So time of ascent, this is part, and this is time of descent. Definitely they are not equal, we understand this part. Okay, so time of ascent would be little less and time of ascent would be little large value, greater value, we have to understand. And what is the final speed that we have to calculate, basic. So this question can be solved in two ways. Very first thing, first you check only ascending motion separately and descending motion separately, you will get the answer. I will discuss it, you will understand. So if I am talking about ascending motion beta, so ascending motion, okay, so ascending motion is there. So definitely you will see here, this particle you are throwing with initial speed of 10 meter per second. So definitely at the highest point its velocity is 0. So we have to calculate time of ascent and you have to calculate height. So just now we have calculated the formula, directly you will put time of ascent is u by g, u is 10 divided by 10, g I am taking 10, that is equal to 1 second, very simple. If I ask you what is the height, so height also very simple thing, you know the u square upon 2g, we can put it this formula, this is 10 into 10 divide by beta 2 into 10, that value is equal to 5 meter. It's a very simple. So this is ascending motion. Now we are going for descending motion. So for descending motion you will understand it. So what is that descending motion, beta? So in descending motion, this particle is coming down. Okay, this is a height. Now total height, because this is already 75, this is 5 meter. So total become 80. That means it is coming down from 80 meter. Okay, initial speed is 0. Now final speed we have to calculate. So what is the speed? We have to put it. Again you will say, so time is equal to, time is under root of 2h by g, we can put it. So you can put that value is equal to 2, h value is how much, beta? 80, divide by 10, it is cancelled, that is equal to 4 seconds. This is time of descent. So time of descent we can put it, that is equal to what, beta? Very simple, 4 seconds. Okay. Now second question comes to you, that is the velocity at the bottom, that is equal to root 2 gh, we are putting it. So root 2 gh under root 2 into 10, what is the h value? H is already 80, if you put it 80, okay. Now you can say this is v equal to under root of 1600, that means it's equal to 40 meter per second. Okay, speed. If you say the velocity, definitely it's the negative, because it's the coming down, because it is coming down, that we are discussing, that we call it velocity at the bottom. Okay, so this type of question comes to you, we can discuss. Okay, now come to the point in motion under gravity. I will discuss one more problem that you have to learn it. Okay. Suppose there is a one tower is there. It's already PYQ question, beta. If the one tower is there, and from this tower one stone A is dropped. Okay, freely fall. And B is dropped after 6 seconds, or actually thrown vertically downward, initial speed V, and at t equal to 6 seconds. It was at t equal to 0, but they both reaches to the ground at the same time after 18 seconds. That means this total time was 18 seconds. Total time was 18 seconds. It is given to you. So question is that what is this initial speed? It's the PYQ. So we have to understand it. What is this V? We have to calculate. I am repeating again. A reaches in to the ground from this top of tower. Okay, that is in 18 seconds. Second stone is actually thrown vertically downward with initial some speed V at t equal to 6 seconds. At t equal to 6 seconds. Now question comes to you, ki what is the initial velocity of the second particle, that we have to calculate. So very simple thing. First you already know ki what is the time is given to you, initial velocity you know, so we can find the height first. So height we can say very simple, h is equal to half g t square. So if you put it, half g value is 10 into this is a total is 18 into 18, you can put it. So from here this become 9, you can multiply, that is equal to 72, 9 and 7, this is a 16. Okay, this would be 16, 0. Okay, that is equal to height. It is the height of this tower, 1620 meter. Now using this tower, from that another stone was thrown, but it actually travel only 12 seconds, because at t equal to 6 we had thrown. So we already know that is distance. So I can apply now second equation, x equal to ut minus half gt square. Already we know this height, that means actually downward, so we will take negative, that is equal to minus 1620. Initial speed also negative, that would be, we can say v, but it travels for 12 seconds. You can put 12 minus 1 by 2, it is 10 into 12 into 12. We can use it and we will try to solve this part. So from here you can say this is a 6. Okay, so that would be minus 1620 and it would be how much? 72, 720. So that would be plus 720 is equal to minus 12 into v. So from here that would be approximately 900, minus is equal to minus 12 into v, minus cancel, v equal to 900 divided by 12. If you divide it, that would be value from if 6, that would be 2, from 6 this would be 1, 0.50, that would be 75 meter per second, that we can talk about it. So you can check calculations also, but the basic concept we have to understand it. This type of question also comes in paper, we can discuss it. Understood? So this is a basic type of question that we call motion under gravity. Okay, now I am discussing one more point that we call it actually Galileo ratio. So when we are talking about Galileo ratio, so what is the meaning of Galileo ratio? Ratio is very simple. Suppose a particle, the condition is Galileo ratio, the initial velocity should be 0 and acceleration should be constant. If acceleration is constant, then we can use this part. So initial velocity 0 and acceleration constant. Then you have to understand that to cover equal distances, okay. So this time interval T1, this T2, this is T3, this is T4. The ratios are T1 is to T2 is to T3 beta is to T4. What is the ratio? Ratio is equal to 1 is to root 2 minus 1 is to root 3 minus root 2 is to, okay, and root 4 minus root 3 is to, like this is going on. Clear? Similarly, one ratio, second ratio we are discussing here. Suppose this is the A to point B, you are reaching, and definitely initial velocity should be 0 and acceleration should be constant, no doubt about it. Now in this case, if you are moving for equal time interval, time is same, this is time is same, this is time is same, and here the distance covered are suppose x1, this is x2, this is x3, this is x4, it is x5. So we have to find the ratio of x1 is to, x2 is to, x3 is to, x4, okay, is to x5. That value would be beta how much? 1 is to, 3 is to, 5 is to, 7 is to, 9. That's the very basic thing that we are discussing. Okay, odd numbers. These are odd numbers. So we are discussing that odd numbers ratio are there, that Galileo ratio we are using it. Okay, this was the first chapter we are discussing, and there are a lot of things are there. We with the time we can discuss further. So I am now taking the second chapter that we are talking about the motion and motion in a plane. Motion in plane. When we are talking about motion in plane, so you have to focus on the few things, that the vectors. So very first thing is vectors, and actually equations of motion in vector form that I am talking about, and next is the projectile motion, next is the relative motion that I am going to discuss, relative motion. Now try to focus here. When I am saying vectors, so vectors we have to understand that there are two types of quantity that we call it scalar and vector. When we are talking about the scalar quantities are those quantity which is having only magnitude, there is no direction, okay, that we call it scalar. Okay, one more thing is the tensor quantity. Actually they are having magnitude as well as direction, but they do not obey vector algebra, they do not obey parallelogram law, they do not obey triangles law. So those type of quantity also we call it actually beta tensor quantity, but in our syllabus tensor is not there. I am talking about the NEET syllabus, try to understand it. So NEET syllabus, the tensor quantities are not there. So generally we consider those quantity also scalar. For example, electric current. In electric current is a tensor quantity actually, because it's have a magnitude as well as direction, but we consider them scalar. Similarly, if I am talking about time, time is also beta tensor quantity. It's always move in forward direction. Right now, suppose time is 10:18 a.m. So, but it cannot go back to the 10:16, 10 o'clock or 9. It is not possible. It is not possible in any possible way till now. Okay, so this is a tensor quantity. It is having particular direction in the forward direction. It is no backward direction. That we call it tensor. Okay. Similarly, some more quantities also there. Stress is there. That is also tensor quantity. So we have to understand, but we consider them scalar in our syllabus. Okay. Now come to the next point that we call vector quantity. Vector quantities are those quantities which is having magnitude as well as direction. Which is having magnitude as well as direction. That means they also obey the vector's law of addition. They also obey vector law of addition. Vector law of addition, when we are saying, meaning is very simple. That means the triangle law or parallelogram law. I will discuss them, you will understand. Suppose I am taking a one vector. Suppose this a vector is there. Okay, this a vector is there beta. Okay, and this is one vector, and you can take suppose one more vector. I am just taking it. Suppose this is another vector there. It is the A vector, this is B vector. I want to add them. So if you are going to add, so very simple, you can add like this. Okay, this is very simple, and you can join that. We can say the R vector. Okay, this is the A vector, this is B vector, that we call it R vector. Using the parallelogram law, you can write R. R would be under root of A square plus B square plus 2AB cos theta. Similarly, I can define one more term that we call tan phi. This angle is phi. So if I ask you tan phi, that would be B sin theta upon A plus B cos theta. A plus B cos theta, that we call tan phi. Suppose you want to find this phi, I can say this angle I can say this angle beta, that I am saying alpha. So if I ask you, you are writing tan alpha would be A, actually A into sin theta divided by B plus A cos theta. This is a very basic thing that we can discuss generally, but we are focusing on these two results, first two results that we are writing it. Okay, now some special cases are there, we can put it. What are the special cases? If I say if A is equal to B beta, okay, and A equal to B, I am writing it, then what the R would be? R would be, you can write it, suppose this is A square plus 2A into cos theta. So from here you can say R vector is equal to under root of 2A square plus 2A square into cos theta. So from here 2A into 1 plus cos theta, that would be actually cos theta by 2. You can use it. It's also very standard result. We are using it for our calculation. Okay, and from this tan phi value would be actually, that will be theta by 2. So if vectors are equal, the resultant is between them angle along the angle bisector. Along the angle bisector we are using it. That is equal to theta by 2, or resultant is equal to 2A cos theta by 2, that we are using. Based upon this, there are some important result we are using for our calculation, that I am just telling you. Try to understand. Very simple. Suppose there are two vectors beta. This vector is A. This is also magnitude is A. It is A. Its magnitude is also A. If I ask you what is the resultant, resultant would be 2A. Very simple result that you have to use it. 2A. Beta 2A. Okay. Similarly, one more is there. One vector is A, and second vector is having a magnitude also A, but in opposite direction. So resultant would be 0. Third is suppose this is a A and it is also A, okay, and this angle between them is 90 degree, then resultant would be equal to A root 2. Similarly, fourth is suppose there is A vector beta and it is also A, angle between them 60 degree, then resultant is equal to A root 3. Next is if I am talking about here, fifth one, you can use it. Suppose it's A, second vector also magnitude having A, this angle is 120 degree, then resultant is equal to beta A only. So this is a very standard result, already 2 times in PYQ. Okay, if there are two equal vectors, equal magnitude vectors, and angle between them would be what if their resultant also the same vector, so same magnitude, that means two vectors magnitude equal and their resultant magnitude also equal, that means angle between them is 120 degree. It's a very standard result, and very commonly they ask the question. I'll tell you some more problem that are based upon the vectors that you have to understand. Very first example I'm just telling you. Suppose it is given to you कि A magnitude is equal to B magnitude, and it is given to you A plus B vectors magnitude is equal to 2 times of A minus B vector magnitude. It's a given to you. Now they are asking find the angle between them. Calculate the angle between A and B. Calculate angle between A vector and B vector. It's the very basic question, that is already PYQ question that we have to understand it. So how to solve it? Just focus on the board, you will understand it. Okay, I'm just discussing here beta. So you will say directly from here that A plus B, if you are writing it, that would be how much? a square plus b square plus 2ab cos theta. You are writing it. When you are writing, that is the 2 times under root of a minus b, that would be a square plus b square plus 2ab, but cos how much? Theta or 180 minus theta? So that would be 180 minus theta. I am just explaining you also. That is equal to 180 minus theta beta. What happened? Suppose this is the a vector and I am saying this is a b vector beta. So this is the angle between them and we are finding this resultant that we call it r. Okay. Similarly, I define one more vector. Suppose this is the here in this action, that is a minus b vector. This is a vector. So resultant of these two vectors would be here, that I am saying s vector. Okay, this is the r, its resultant is s vector. But this angle is how much? 180 minus theta. So that's why I am writing as 180 minus theta. So you can use it and you can solve it. Now try to understand. You can square both sides and a and b are equal. Put it the value. It would be a square plus 2a into a into cos theta. It would be 4 times of, it is also a square plus 2a into a into cos 180 minus theta, that is equal to what beta? That is the cos theta only. Okay, with minus sign, with minus cos theta. You can put it, that is the minus cos theta. That's the very basic thing. Now put the value. This become 2a square taken common, so this become 2 plus 2 cos theta. That would be 4. Similarly, it would be 2 minus 2 cos theta. Okay, 2 also we can remove from both sides. So what this will become beta? That would be 1 plus cos theta is equal to 4 minus 4 cos theta. It would be 5 cos theta is equal to 3 and cos theta is equal to 3 by 5, and we already know this angle is equal to 53 degree. So angle between a and b would be 53 degree. That is the question, very simple, we can discuss it. Okay, so this type of basic question related to the vectors comes to you, we can discuss it. Understood? So what are the vectors question that we can discuss? I am just telling you one more problem that you have to understand related to the vectors. So you have to understand how to take resolution also. You will see the question. Suppose if I say here that there is a one block. Don't confuse, this is not next chapter question, but we can understand it. Suppose there is a 10 kg block and this angle is 30 degree. It is a 60 degree beta. It is already one this type of question you will find in P by Q already there. So now question is this tension is T1, this tension is T2 and this tension is T3. We have to calculate T1, T2, T3. We can discuss very simply and we can understand it. Understood? So how to calculate this T1 and T2 and T3? So for that we can use a very simple thing that we call the Lami's theorem also. We can use it, we can understand it. Okay. So I am just discussing very simple. This is 30 degree, this is 60 degree, total become 90 degree. So definitely this angle also 90 degree. It is 90 degree. If you draw the here dot, so you will understand this is 30, then this is also 30, then this total angle become how much? This was angle was 30 degree beta, then total angle become 120 degree. Similarly, this was 60 degree, so this total angle become 150 degree. So T1 already everyone know, okay, T1 is equal to what? 10G. 10G means 100 Newton. I can use it. G value 10 I am taking. So from here Lami's theorem we already know, that is equal to what beta? A by sin A, sin alpha, or B by sin beta, divided by C by sin gamma. That means opposite angle. So I can write Lami's theorem also. If you put it, say suppose these are 3 vectors, suppose this is the A vector, so opposite to that we call it alpha, this is B vector that we call it beta, and opposite to C vector we call it gamma. So opposite to A that we call it alpha, opposite to B we call it beta, and opposite to C we call it gamma, and we are using this concept here and we can put it. Okay. Now what is this value? Beta T1. So T1 opposite to this T1, this is sin 90. So you can use sin 90 is equal to, this is T2. T2 opposite to T2, that angle is 150, so you can say sin 150 degree. Similarly, this is a T3. Opposite to T3, that is angle is a sin of 120 degree. Now we have to solve this value and we can get it. So simply we know the T1 is equal to how much? 100 Newton. So you will say 100 divided by sin 90 is equal to 1. Okay, that is equal to T2. T2 divided by how much value? This is sin 150. Sin 150 is equal to 1 by 2 equal to sin 30, and T3 that is equal to sin 120, and that is the equivalent to the sin 60, that means root 3 by 2. Now from here if I ask you T2, T2 would be how much? 100 divided into 1 by 2, that is equal to 50 Newton. Similarly if I want to calculate T3, T3 would be how much? 100 into root 3 by 2, that is equal to 50 root 3 Newton. That's the answer. So this type of question also comes in paper, so we can understand how to, using the Lami's theorem, we can solve the questions. Okay, now we can understand those basic type of problem. Now we are moving to the next problem that we call it projectile motion. What we are discussing beta? Projectile motion. So try to understand projectile motion. Okay, suppose one particle is there and I am just throwing with the initial velocity u at an angle of 30 degree or any theta, I am taking general. Okay, suppose this angle is theta and it is going somewhere like this horizontally, some distance. This is the horizontal direction actually beta. It is a horizontal and it's the vertical direction. It's the vertical direction. So try to understand here to here that distance we call it r, range. This is the maximum height, I call it h. Okay, and the total time of this is we call time of ascent, this is time of descent. Total distance, total time we'll call it time of flight. So we have to calculate that thing. So it if I'm saying this motion, projectile motion, it is equivalent to actually what beta? Two motions. One is horizontal and one is vertical. One is horizontal motion, one is vertical motion. So just give me 1 minute, I'll take some water. Now, when we are talking about the horizontal and vertical motion, when you are seeing horizontal and vertical, so if you see the vertical, what is happening here beta? So please understand. So there the velocity would be having two components, that is the u cos theta beta, and this component is we call it u sin theta. So there are two components. So when we are seeing here that component, vertical component is the u sin theta. It is going upward and returning back, that's the one thing. Plus one horizontal component was like this. This was the u cos theta and it is reaching somewhere from A to B, that we call it r, range, and it travel for time interval t. It is u sin theta, it is reaching up to the height of that we call it h, and this time is time of ascent and this is time of descent, and total time of flight we know. Definitely it will return with the same speed, that is equal to u sin theta in vertical downward. So if I ask you what is time of ascent here, so directly you know the u by g means u vertical, that means u sin theta divided by g beta. Okay, that is equal to time of descent also. So time of flight, if I write it, that is equal to 2u sin theta by g. It's a simple thing. So 2u sin theta by g, that is we are writing. Similarly, if I ask you what is the height, maximum height, so if you are saying maximum height, h is equal to, that is equal to u y square upon 2g. That means vertical velocity, that is equal to u sin theta whole square divided by 2g, that is equal to u square into sin square theta divided by 2g, that we are using it, that is the maximum height attained by this particle. Maximum height attained by this particle, we are using it. Second is the range. Range we are taking, so range is equal to what beta? U horizontal velocity multiplied by time of flight, that is equal to u cos theta multiplied by actually 2u sin theta divided by g. 2u sin theta divided by g, if you are using it, that would be u square into sin 2 theta divided by g, that we are saying the range. So these are range, what is the maximum height, what is the time of flight, what is the time of ascent, what is the time of descent. This is a basic question that comes to you, you can discuss it. Okay, understand it. Now using this basic formula, we have to understand some more thing. What is happening in horizontal direction, only one thing is there, that is the velocity, there is no acceleration. That means acceleration is 0 in horizontal direction. That means velocity would be constant. Velocity would be constant. That's a very important concept that you have to learn it. Okay, so Harshita, definitely I will cover the river boat problem in detail. Don't worry about it. Any topic, especially wherever you are feeling any problem, you can put it. You can write it and comment. So it would be good. You can ask your friends. They can put their problems on the chat box. That would be good. Okay. So I am starting again, and I am just saying here the range we have to know. So in horizontal direction, in what is remains constant, that the velocity will remain constant. That is not going to change. If horizontal direction the velocity remains constant, that means it will everywhere would be same. So based upon that concept, there are some questions already in PYQ. We will discuss. We will understand it. Suppose if I say here beta, and I am saying this is a u and this angle is theta, I am throwing it. So they are saying after some time this velocity is making angle phi with the horizontal. The question is that what is the velocity at that point of time and what is the time instant, that also they are asking it. So you have to understand, suppose this time velocity is v, so there would be two components, this is v cos phi and that would be v sin phi. So try to understand, initial was the u cos theta and it would be u sin theta. So horizontal component remains same. So you have to understand very clearly that the v cos phi is equal to u cos theta. That is not going to change. So directly you can say v equal to u cos theta divided by cos phi. So that is a very basic. We can understand. We can learn it. I think everyone is having this clarity. This is a very simple question, already PYQ question. Okay, in J1 they ask this question. Now try to understand, second question is there. Okay, what is the time instant? So time is always calculated from the vertical motion, not horizontal motion. Horizontal motion never it will give you the time. Time is always given by the vertical motion. So from vertical motion you will ask the what is time. So you will say directly the final velocity we know, initial velocity we know. So we can put the first equation, we can get answer. So Vy is equal to Uy plus Ay into t. So what is final velocity? That is equal to V sin phi is equal to U sin theta, okay, minus G into t, that we want to calculate. So from here you can say sir Gt is equal to U sin theta minus V value we already know, that is equal to U cos theta divided by cos phi beta, okay, and multiplied by sin phi. That's the very simple thing. Now I want to just solve this part. If you solve it, what you will get? That is equal to G into T is equal to, you can take U common, bracket, that value would be sin theta into cos phi minus cos theta into sin phi divided by cos phi beta. It's the cos phi. It's the very basic thing. So from here directly you can say this is actually t value would be u. G I am taking this side, G into cos phi, and this value is nothing as sin A cos B minus cos A sin B. That means sin A minus B formula. So you can say this is sin of theta minus phi. It's the simple result that we are going to write it. This is time instant from here to here. What is the time interval? That is the time interval they are asking it. Directly we can calculate. Understood? That's the simple that we call projectile motion. Basic some more problem I am just discussing. Suppose there is a one tower is there, and from this tower I am just throwing, suppose it's a 40-meter tower, and from this 40-meter tower you are throwing one ball with the speed of 20 meter per second, and they are saying when it reaches to the ground, so what is the range, what is the time of flight? They are asking these two questions. What is the time of flight, what is the range? That we call horizontal projectile. What we call it? Horizontal projectile. So for the horizontal projectile, again you have to see the very simple thing. What is the horizontal motion and what is the vertical motion, that you have to put it. So if you are putting horizontal and vertical motion one by one, so you will understand it here beta. So very simple. That would be two cases. One is a horizontal. If I am talking about horizontal motion, that is nothing else. It is moving with the the speed of 20 meter per second. Suppose for time t, that is the range. I am saying r. And second is what beta vertical motion. So it is just dropping from the tower. You're dropping from a tower, that's the 40 meter. Okay, dropping, because vertical motion initial velocity is 0. So it is just coming down. So this is time of flight. So what is time of flight? Everyone knows t equal to under root of 2h by g. So you can put t equal to under root of 2 into 40 divide by 10. If you cancel it, that would be 2 root 2 second. So this is time of flight that you can put it. If you know time of flight, using this time of flight, we can calculate what beta range. The range would be very simple. That would be horizontal velocity multiplied by time of flight. Horizontal velocity is already 20. 20 into 2 root 2. That would be how much? That would be 40 root 2 meter. That's the range. So this type of question comes to you in a projectile motion, basic question that I have discussed, and we can understand the basic concept of the projectile. Now move to the next topic that we are discussing, that is equal to relative motion. So in relative motion, definitely riverboat problem is going to cover. Okay, so first thing is the relative motion. I am just telling you beta, try to understand. When I am saying relative motion, focus. Very simple. Ki suppose velocity of A with respect to B I am saying. That means velocity of A minus velocity of B. Similarly, if I say acceleration of A with respect to B, that means acceleration of A with minus acceleration of B. Similarly, if I say the position of A with respect to B, that means position of A minus position of B. These are few basic results that you have to understand first clearly. Okay, now try to understand it. Using this part, I will just discuss some questions. Already basic PYQ questions also. If suppose there is one car is there beta. Suppose this one car I am saying it is moving on a horizontal surface and it is moving with the speed of suppose 10 meter per second. Okay, this is the velocity of car, and there is one man is there. Okay, and this man is here and it is also moving in the same speed with the speed of 2 meter per second, and there is another man is there that I am saying B. It is moving with the speed of 4 meter per second. So now question is that find the velocity of car with respect to A first. Second is the velocity of car with respect to B, basic. Second question. These are two basic questions they are asking it. So how to cover it? Directly you will do very simple. I can put it velocity of car with respect to A. That means velocity of car minus velocity of A. I can put it. Velocity of car I am taking in a positive direction. Suppose this is 10 meter per second, and A is also positive direction, that is equal to 2 meter per second. So that would be only 8 meter per second. The velocity of car with respect to A would be 8 meter per second. If I say velocity of car with respect to B, that would be velocity of car minus velocity of B. You can put it, that is the 10 meter per second beta, positive, minus, but this is moving already in negative direction, that is a minus 4 meter per second beta. So that would be minus minus plus, that would be 14 meter per second. It's added. So what you understood, if the particles are moving in same direction, their speeds are subtracted. If they are moving in opposite direction, their speeds are added. So we are doing the same thing, we have to understand it. Now second type of problem comes to you that I will discuss. Comes to here. Suppose very basic, there is one aeroplane is there. Okay, one aeroplane is there and it is moving in northeast direction. Suppose I am saying in the northeast direction, there is one aeroplane is there. The velocity of aeroplane, and it is equal to, suppose I am saying you 400 meter per second. It is covering a 400 meter per second. Okay, and there is one wind is there. This is east direction, this is north, it is south, and this is west direction. Try to understand it. And this angle given to you at a 45 degree. Very simple. But wind is moving here. Wind is moving here, beta. Okay, towards north or due north. That wind velocity is given to you, suppose 20 meter per second. It is given to you. Now question is that what is the aeroplane velocity with respect to ground? What is the aeroplane velocity with respect to ground? That's the question. So this type of question when comes to you, you have to be clear where the aeroplane is actually moving. Inside the wind only. That means here they are not subtracted, they are added. They are added. It is similar to the, suppose river is there. If I place one wooden block or the block on the river, then what will happen? It will also move with the same direction of the water. Water is moving suppose 2 meter per second, the block is also moving almost 2 meter per second if we neglect all the friction forces. Okay, so it will also move with the 2 meter per second. That means the river velocity is given to the block. Now think carefully, in the same river, if there is a boat is there and boat is also moving towards the same direction of the river flow, so river flow is 2 meter per second and the boat is also moving by its engine, that is 4 meter per second. So with respect to ground, what is the speed? 4 plus 2, that is equal to 6 meter per second. So with respect to ground, that would be 6. That means they are added. They are added. Why it is added? Because the boat is not independent. Boat is inside the river. Try to understand. Whenever inside word is there, then you can understand. One more example I am giving. Suppose one train is there. Okay. Suppose metro is there and the metro is big. You know the big coaches are there. Suppose metro is moving with the speed of 20 meter per second. In the same direction, I am inside the metro and I am also moving in the same direction with the 4 meter per second metro direction. Then what will happen? With respect to ground, my speed would be what? 6? No. It's the 10 plus 4, that is equal to, you can say 14 meter per second. Okay, so 10 plus 4, that is the 14, if I am assuming the metro speed is 10 meter per second. Come to the second question. If suppose the metro is moving 10 meter per second and opposite to that, if I am moving with the 2 meter per second, then what will happen? Speeds are added or subtracted? Subtracted. It is just like upstream case of the river. So we have to subtract it. So whenever inside term is there, subtract. But they are independent bodies. Now if you see here the car and A, they are independent. They are not, A is not sitting in the car or a car is not sitting on A. So you have to understand it, how they are independent. Then you have to same direction subtract, opposite direction add. But when you see inside term is coming, okay, then you have to same direction added and opposite direction you have to subtract. This is a very, very common question is there that you have to learn it. Now, there will be two components. You can take the component of this vector beta. What is the component? One would be how much? 400. I can take, for simplicity, you can take 400 root 2 meter per second. This would be 400 root 2 into sine cos 45 beta. Cos 45 1 by root 2, that means 400 meter per second. And it is also same 400 root 2 into sine 45. Sine 45 also 1 by root 2, that means this is also 400 meter per second. So you will say कि sir velocity of aeroplane actually how much beta? Velocity of aeroplane we are writing it 400 I cap plus 400 j cap. Okay, but velocity of wind is how much beta? That is equal to 20 j cap. So when you are saying velocity of aeroplane with respect to ground, you have to add both of them. Don't subtract. That thing I am just telling you. So if you add it, so what will happen? This becomes 400 I cap plus 420 j cap. I cap means east direction, j cap means north direction. We can write it. Okay, this is the final. If you want to find the magnitude aeroplane with respect to ground, that would be under root of 400 square plus 420 square. You can solve it. I am leaving for you. Second thing is what is the angle actually. So if you see the angle, so this will be very clear. Okay, suppose this is east direction, this is north direction beta. So final velocity would be somewhere here. So if you see here north direction, that is the 420. In east direction, that is equal to 400. If I want to calculate this theta, can you calculate theta? Definitely. Tan theta would be perpendicular upon base. Tan theta means perpendicular upon base. What is that perpendicular? 420 divided by 400. So that would be how much beta? 0, 0 cancel. So this would be 21 by 20. You can write it tan theta is equal to 21 by 20. Or you can write one more thing here. That is equal to beta theta equal to tan inverse 21 by 20. I can write it, and this is what beta? North of east. North of east. That means here this aeroplane is moving towards north from east. So that is the way to write this thing. So this is a way to write this thing that you have to learn it. That is the north of east, 21 by 10 inverse 21 by 20. Clear or not clear? Now the second thing I am just discussing, that is the river boat problem. So now try to understand it. Okay. Now try to understand the river boat problem is there, beta. River boat problem is the two kind of problem. Very first thing, the 1D. If I am talking about the one dimensional motion, the one dimension, suppose this is a river is there and it is moving in this direction, flowing in this direction, river. So the one the boat is there, beta. It is moving from A to B, okay, or B to A. They can be two possibility. So suppose A to B it is moving. One boat is there. It is moving this direction. That means we call downstream. If it is moving from B to A, that we call it upstream. So suppose boat velocity is given to you here already 4 meter per second, and river velocity given to you 2 meter per second. Okay, and suppose this total distance is 100 meter. Now very first thing, or 120 meter I am giving you, 120 meter. It's the 120 meter. It's the 120 meter, beta. Now question is that what is the time to go from A to B and B to A? That total time we have to calculate. So A to B and B to A we are discussing. So time taken from A to B. A to B we call it downstream. It's the downstream. And downstream means what will happen, beta? So you will say that both are moving in same direction and the boat is inside the river. That means their speeds are added. So you will add both of them. If you add it, that becomes 6. So directly you will say that time is equal to T1, I am writing it. So that would be the distance, that means 120 meter, and speeds are added, that would be 4 plus 2, that means 6 meter per second. So total is equal to 20 seconds at the time. If you go for a reverse part, that is equal to time taken from B to A. B to A, that means we call upstream. Upstream means opposite. Okay, opposite, they are moving to the flow. Opposite to the flow, that means their speeds are added, sorry, subtracted. So if you subtract it, so this is 4 minus 2 meter per second. So this is 4 meter per second and this is 2. So total become 2 only. So T2 would be 120 meter divided by 4 minus 2 meter per second. If you are putting it, so total is equal to 60 seconds. If I ask you the total time would be T1 plus T2. You will add it, then you will get what is that value, beta? T1 plus T2. So T1 plus T2 is equal to how much? 20 plus 60, that is equal to 80 seconds at the final answer. We can put it. Now second type of problem comes to you that we discussing, the river boat problem. There is a two-dimensional problem. So two-dimensional means this boat want to cross from one bank to the another bank. That question we are discussing. So suppose there is one river is there. It is flowing with the speed of VR, and you want to cross it from A to B, like this. A to B you want to cross it. So how to cross it? Very simple thing. So there can be two possibilities. Either you are going for a minimum time or you are going for shortest path. So suppose you are going for minimum time. So minimum time you are going like directly this A to B, directly you are going, okay, then you will reach somewhere here due to river. You will reach somewhere here towards C. Because if I assume it, this direction beta x-axis, and I am assuming suppose this direction is equal to y-axis, and this separation is equal to I am assuming d, and this the boat velocity I am saying VB, and this river velocity we are seeing VR. So try to understand this distance d is covered by only this velocity, because along this y-axis only one velocity component is there. But due to this river flow, the velocity is along x direction. So what will happen as boat is reaching A to B, due to this river flow, it will push down towards the downstream. So it will reach somewhere C. So this distance we call it drift. What we call it? Drift. So this is drift is there. Okay. So we have to calculate time also. We have to calculate the drift also. If I ask you the time, that will be actually minimum time to cross the river. So this is T minimum I have to write. So T minimum would be what? D by VB. D by VB. Okay. That we are putting it. And second thing is water drift. So x is equal to, very simple, you will say directly VR into T minimum. You can say T minimum. You put the value, you will get the answer VR into D by VB. That I am talking about this. This is the T minimum and x. Clear that we are writing it. And second case comes to you. Okay, suppose you want to cross it in the shortest path. Suppose it's a river beta, and you want to cross from A to B. You are clear about it. Ki you have to go like this only. So river is flowing in this direction, that's the VR. So if you are going along this path, so definitely river will push down to you. So that means you have to move not towards directly to B, you have to move towards this direction C. But due to this river flow, you are pushed to the B. That means you are reaching to the B, that we have to understand it. So what is this value? This is river boat velocity. This angle I am saying theta. So this would be VB cos theta. And this would be one component that would be called VB sin theta. But one component is there, one velocity due to this river also there VR. This we call x-axis, this we call y-axis. Everyone understand this basic part. That's the D. So if I ask you what is the very simple thing, what is time to cross the river? So if you say the time is equal to what beta? D by VB cos theta. And second thing, along x-axis, what are the things? Along x-axis, what is the displacement? 0, because I want to go directly A to B. So along x-axis, the displacement 0, then velocity should be also 0. That means along x-axis, velocity should be 0. That means VR is equal to VB sin theta. So from here you can say, sir, sin theta is equal to VR by VB. VR by VB, that is the sin theta. You will make a triangle. It will help you to solve the value. That would be VR, this is VB beta, and that would be under root of VB square minus VR square. Using this part I can put it and I can calculate the time also. So you will say T is equal to D by VB. What is the cos theta? Cos theta value would be root over VB square minus VR square divided by VB value. So you will VB cancel. So time is equal to D upon under root of VB square minus VR square. I can put it, you will get the answer. Okay, this is a river boat problem that we can discuss it. Okay, any problem is there, please put the in chat box, that would be good. Okay, use be active little bit beta inside the class. So inside the class, if you are a little active, okay, I understand there are only few people inside the class, but be active. Okay, now try to understand. Now I am taking another case, that case is a rain man problem. So rain man problem is there. So suppose one man is there and is standing here, and rain is falling like this. Rain is falling and this is the rain velocity. Suppose it's a 3 meter per second, and this man is moving in this direction, V man, that is equal to 4 meter per second. Okay. Now question is very simple. Question is there, ki what is the velocity of rain with respect to man? So if you are saying velocity of rain with respect to man, so you will say velocity of rain minus velocity of man, or you can say velocity of rain plus minus of velocity of man, that we can discuss. Very simple. That's the velocity of rain with respect to man. It is clear. So I am just drawing it. If you draw the graphically, you will understand it. Okay. So try to see. This is the horizontal direction. It is the horizontal. It is vertical. There should be no confusion. It's the vertical. It is not east, west, north, south. Try to understand. So in this case, what is happening? This is the rain velocity, and man velocity we have to draw in negative direction. So that means this side I will draw. This is the main velocity. This value is how much beta? 4 meter per second. This value is how much? 3 meter per second. So the resultant would be somewhere here, and that value would be velocity of rain with respect to man. That means velocity of rain with respect to man, that would be root over, that is equal to 3 square plus 4 square, that is equal to 5 meter per second. That means velocity of rain with respect to man is equal to 5 meter per second. I think it is clear to you. that type of basic question comes to you in the paper, we can discuss. So this topic is also over. Now we are going to start the new topic and we are going to discuss, that is the laws of motion. Try to understand it. Laws of motion. When I am talking about laws of motion, okay, in laws of motion part topic, what is there, beta? That the very basic thing is there. In this chapter we will understand what are the laws first. So first thing is the laws. What are the 3 laws are there, and after that I will talk about the momentum. Okay, then I will discuss the law of conservation of momentum. Then I will discuss next point, that is equal to change in momentum. Change in momentum and impulse. Okay, next I will discuss the forces, different kinds of forces. Okay, in the forces, very first I will discuss the variable mass problem. Next thing I will discuss, that is equal to tension, beta. Normal. Next is the friction. Okay, pseudo force. Next I will discuss the spring force. Okay, don't worry about the circular motion, I will cover all together. That means in next chapter I will discuss that all different kind of circular motion. It may be horizontal, vertical. Okay, or I can put here also circular motion, no problem. That's the circular motion. Okay, circular motion, I will put it. These are topics we are going to discuss. The very first thing comes to you, what are the laws of motions. So very first thing, what are the laws of motions are there? There are 3 laws given by the Newton. What are the 3 laws? Very first thing is the first law is what, beta? And that is the Newton's first law, that we call as law of inertia. Law of inertia means if any body is at rest, it remain at rest. Hi Pavan. Okay. So any doubt is there, you can put the topic, we can discuss that topic also in detail. Okay, and any other students inside the class, please you can put the things. Okay, so I am just returning to the topic, that we say the laws of motion. The very first thing is the first law is what, beta? Law of inertia. Law of inertia means body is at rest, then it remains at rest. So if body is in motion, it remains in motion until unless any external force is applied on the body. Until unless any external force applied on the body, that we are talking about it. Okay, so it will remain at rest, or a state of rest, or a state of motion. So very first question comes to you, what is the inertia? So inertia is the actually one property. Due to that, the body does not want to change its state of rest or state of motion. Okay, that is the property, and this property is directly related to the mass. If mass is more, definitely the inertia of body would be more. Okay, so it is directly related to the mass. So second is the inertia is 3 kinds of. First is the inertia of rest, inertia of motion, inertia of direction. So when we say inertia of, if I say at rest, inertia of rest means if a body at rest, it does not want to go into the motion. So due to that, we have seen the few things. Suppose I am sitting in a car and suddenly we start the car, so we fall backward, or bus we are sitting, so we suddenly fall backward. So why we fall backward? So very simple thing is because our lower part of body, which is in contact to the bus, it come in motion, but our upper part of the body is not in motion. It want to be remain rest, so that's why we fall back. And similarly, if you come to the second topic is there. If I am talking about inertia of motion, so suddenly a car is moving and suddenly we have to put the brake. Then what happen? Our body, upper part of the body, come into the motion, and it is a falls in forward action. That's due to inertia of motion. Third thing is the inertia of direction. When we are talking about inertia of direction, suppose I am taking a one stone and it is tied with the one string and I am just whirling like this, okay, and suddenly this is what happened, the string is, I left it, or this string is broken, then what will happen, it will go in a straight line. After that it will fall in a parabolic part, that is a separate thing, but at that point of time this will move in a what, straight line, that we call tangentially it will go. Similar question comes to you, suppose in an atom, if due to some reason the electromagnetic force becomes zero, then electron revolving around the nucleus, it will go in a straight line. Similar question we can discuss, suppose Earth is rotating about the nucleus in a horizontal, in a circular motion. If suddenly the breaks, suddenly gravitation force become zero, then the Earth will go in a straight line, tangentially straight line, due to inertia of direction. That means until unless you are applying any force, direction cannot change, okay, of a motion. Okay, Pavan, actually I have discussed already, you joined little late, don't worry about it. So my request is, when this recording would be over, so at the end you can check it, you will find in the channel, you can subscribe, you can edit, and you will find straight line also I have discussed, motion also, motion plane also I have discussed better. Okay, so now I am discussing the third chapter. If any problem is there, please please remove this. Okay, thank you. Okay, so no problem, very good morning Rohit. So we have to discuss this thing, no problem, please join and you will understand the things. Class I'll try to cover 12, but if little later, then be in touch. Okay, Ramesh, no problem. So we are just discussing that the law of inertia, first law. Second law is a very very important law, that we call actually actual law of the, our heart of the, we can say the mechanics, the very very important law, that we call it F equal to ma law. So F equal to ma law, what is the meaning of that? That means this is the F equal to, if I am saying that is equal to dp over dt. This is the second law. What is the meaning of dp over dt? That means it is a very simple thing. The rate of change of linear momentum of a body, rate of change of linear momentum of body, it directly proportional to the force applied on the body in the same direction. Understanding? So force applied on the body in the same direction, we are putting, that means F is equal to dp over, that the very very important thing that we have to learn it. So F equal to dp over dt, I am putting it. So what is the p? P is the linear momentum. So this is a very important law. Try to understand, this is a very very standard form of the second law. Now come to this part, I can say F is equal to d over dt. Now that we can put it m into v. If you differentiate, you will say directly m into dB by dt, one law, one part, and second part would be v into dm over dt. Okay, that's the very very basic thing we can put it. So this is the second form we can write. Now third thing we can write it, if I say if mass is a constant, if mass is constant, that means this term would be 0, because dm by dt would be 0, mass cannot be changed. So I can put it, so that F is equal to m into dB by dt. So dB by dt with acceleration, that means you can say m into a. So that's why most of the time we use this equation, that we call it F equal to m equation. Okay, Ramesh, actually I was covering up to the rotation. I will try to cover the rotation as much I can do. Okay, so this time I'm right now I'm discussing the laws of motion, then I will go for the work, power, energy, and I will try to cover maximum part of the rotation also. Okay, so try to be in class. Now this m equal to constant, the F equal to m into dB by dt, that is equal to F equal to ma. Second way, if I say the velocity is constant, okay, velocity is constant, but m is varying, mass is varying, that we call variable mass problem. Mass is varying. So this is the second law. If I am putting it, you will say F is equal to, this term would be 0 because the velocity is constant. So second term would be there, that will say v equal to dm by dt, that I am putting it. It's a very basic thing that we call force. Okay, that's the force we are taking it. So F equal to V dm by dt, we can write it. The third thing, if I say here, okay, if F equal to 0, if F equal to 0, what is the meaning of this? You will say, sir, F is equal to dp by dt is equal to 0. Yes. If it is 0, that means P equal to constant. P equal to constant, that we call it law of conservation of linear momentum. Law of conservation of linear momentum. So law of conservation of momentum or law of conservation of linear momentum, that we are writing it that the P equal to constant. What we are saying? P equal to constant. So linear momentum is equal to constant, that we are talking about it. So here we will discuss this thing. Okay. So and now we are going to discuss one more thing. What is the meaning of force? Force is a vector quantity, everyone know. And what is the SI unit? That is the Newton. And CGS unit we call dyne. And what is the relation between dyne and we can say Newton? So 1 Newton is equal to, everyone know, 10 to the power 5 dyne. We are talking about it. The very simple thing, 1 Newton is equal to 10 to the power 5 dynes. So we are just discussing very basic thing that you have to learn it. Now come to the point, what is the momentum? If I am talking about the momentum, if you see the momentum is equal to what, beta? M into V. That is equal to, momentum is equal to M into V. M is the mass and V is the velocity, and it's the scalar quantity, velocity is vector quantity. If you multiplied, final would be vector. What is the SI unit? SI unit would be kg meter per second. Kg meter per second, that's the SI unit. Okay, basic, it's the vector quantity. Now based upon this, if I ask you very basic question, suppose one particle is moving 10 kg mass and is 2 meter per second, what is the momentum? Basic question, everyone can tell. This is equal to mass into velocity, that would be 20 kg meter per second. Definitely they will give you direction, I cap, J cap, K cap, you will put, you will get the answer. Basic question. Second question comes to you related to the law of conservation of linear momentum. Law of conservation of linear momentum. Based upon this, very standard question is a bomb problem. Very standard problem, bomb problem. What is the bomb problem, beta? Suppose if I am taking a one bomb is there, okay, it was initially at rest, this mass is M, it was at rest, okay, and due to some internal forces, what will happen? Definitely, good, Ramesh, good, you are solving, very good. Other people also can take part in the calculation part. I will just, if you're interested, definitely I will give you some time. If this is broken into two parts, it is broken into two parts. Suppose one part is flying, this mass is m by 4 with the speed of, suppose I am telling you 30 meter per second. So now very first question is that, what is the speed of the another part? This mass would be definitely 3m by 4. So my speed, what is this speed? We have to calculate. Can you calculate? Please do the calculation, beta. It's a very simple thing. So how to calculate it? Because it's the whatever the this process happening, this is due to internal forces. Due to internal forces. So due to internal forces, the bomb is broken. So internal forces is broken. That means external force is 0. That means momentum remain conserved. That means P initial is equal to P final. We can put it. That means P initial is equal to P final. There is no problem about it. Initial momentum was 0. Initial momentum is 0. So final momentum, we have to understand it. So what is final momentum? You will say is m by 4 into 30 meter per second. Positive direction. This is 3m by 4 with the v. We don't know what is the value. We have to calculate. Okay. So you can put it value. So definitely m by 4 taken common. You can remove it. 0. This is 30 plus 3v. If you take this side, that is the minus 30 is equal to 3v. So v equal to minus 10 meter per second. Correct. This is very simple. Ramesh, good. You are doing okay. Very good, beta. This is a 10 meter minus 10 meter per second. Minus sign is showing you the opposite direction. Nothing more than that. Very basic question. Now come to the another example I am giving you related to the bomb problem. Okay. Now come to the, suppose there is one projectile motion is there. One projectile is there, this mass is m and you are throwing like this. At the highest point, if you see it, if you are putting this highest point, there are 3 particles. This is suppose m by 4. Okay, it is a false dead. False dead means it is falling vertically downward. Initial velocity 0. Okay, and it was initial velocity u, this angle is theta, and one particle is m by 4 is retraced its path. Retrace means it is returning back to the original position. Retrace its path means returning to the original position. Now this is the m by 2, it is moving some velocity v, that we have to calculate what is the v. Okay, please everyone try, and you can post your answer in a chat box, that would be good. So this is the m by 4, it is also m by 4 returning back. The question is that what is the m by 2 velocity after this explosion. Again I am telling you there is no external force, it is a breaking down due to some chemical reaction, internal reactions, internal forces, okay, that we have to understand. Now Pavan, definitely I will cover after this work, energy and power, and then rotation. So please be little patient, that would be good for you. Okay, so please understand. Now we are going to discuss that the u, that's the u angle, this theta. Now we have to cover the things. So at this point, highest point, we already know the what is the velocity. Velocity would be u cos theta. Horizontal velocity is there. Now it is going to break down into the three parts. How to calculate? Please understand. So you will say P initial is equal to P final. So initial momentum was beta m into u cos theta only. P final. Now what is happening? 1 m by 4 false that means 0. Next is what beta? M by 4 into what velocity? Opposite direction. But this is what beta? U cos theta or u sin theta? U cos theta. But opposite direction means minus u cos theta. Now next is what beta? M by 2. M by 2. M by 2 into what velocity? V. We want to calculate V, that our concern is there. Please understand. So this m I can take common, that I can remove it, that would be u cos theta. This term is 0. This is a minus u by 4. So I will take this side, that would be plus 1 by 4 into u cos theta. That would be 1 by 2 into V. We can put it, this become beta 5 by 4 and u cos theta, okay, that value is equal to V by 2. From 2 this become 2, that means V is equal to 5 by 2 u cos theta. It's the final answer. I think everyone is clear about it. Yes sir, no sir, please put the some in chat box, put the some your reactions, your understanding or not. It is also one problem that we are discussing it. Okay, now I am discussing one more problem is there that we talk about it related to the conservation of linear momentum. Very basic, very standard problem. Suppose I am discussing the one recoil velocity questions. One gun is there, it's a gun, and its mass is there capital M. Okay, and from this part what is happening, one small bullet is there, and its bullet is going into the small m, and this speed is suppose I can say 100 meter per second. 100 meter per second, and its mass is 20 gram, and this gun mass is suppose 2 kg. So what is the recoil velocity that we have to calculate? What is the recoil velocity that we have to calculate? That's the question. Okay, Pavan, I think my technical team will answer you when the school will start in Vijayawada Mayuri Bhavan in IPL Super 60. So definitely they will comment for that. Okay, so right now I am not having that information, but just you will get the answer within a few time. Okay, now come to this part, that is what beta. This is the, we can say P initial is equal to P final, we have to put it. So what is P initial is equal to P final? So what is happening, initially both the bullet and this bullet and gun was at rest, so you can say P initial is equal to 0. So P initial is equal to 0, we can putting it. P final we have to calculate. P final means how much? This bullet is moving in forward direction, so you will say the mass is what, 0 point, you can say 0.2, we are putting it, and is the speed of 100 meter per second, plus this is how much, 2 kg, and moving with the speed of V recoil, that we have to calculate. So from here this is 2, I am taking this side, this is a minus 2 is equal to 2 into VR. So VR is equal to minus of 1 meter per second. That means the recoil velocity of this bullet would be, the gun would be 1 meter per second, that we can discuss. That is the related to the conservation of linear momentum type problem that we have to understand. Next thing I am just discussing, that is equal to the change in momentum problem. Change in momentum type problem is very basic question is there. Suppose I am just telling you here, okay, there is one ball is there and it is coming from this height. Suppose it's a 20 meter. After striking, it is reaching to the height only 15 meter, and this contact is time is equal to 0.1 second. So question is that what are the change in momentum? First question, and second question is that what are the average force acting on the ball? What are the average force acting on the ball, that they are asking it. So what are the average force acting on the ball, that we have to calculate. So how we can put it? Okay. Now connected body beta we will come. Ramesh, definitely I will come to that point, I will discuss it. So this is the first coming from 20 and reaching to the 15 meter, that we have to learn it. So very first thing, what is the initial velocity here? So first velocity v1, this velocity would be v2. So if I ask you v1, that would be under root of 2g into 20. Okay, definitely it's the negative direction coming downside. v2, it is a positive direction, but that would be under root of 2g into 15, that is the positive direction. So you know v1, you know v2. Now we have to write what beta? Delta p. So delta p means what? Change in momentum, that means final minus initial. So if you say final, final would be m into v2 minus m into v1. So you can say m is common. So this would be what beta? v2 minus v1. So v2 value is under root of 2g into 15 minus minus become plus, that would be under root of 2g into 20. Okay, that I am writing it delta p. So this is a very simple type of problem that we can discuss it, change in momentum. I have not given the mass. If you put the mass, you will get the answer. Okay, that's the very simple. Now second question, if they are asking the average force, the average force would be delta p by delta t. Just you have to divide by time. Time is also given to you 0.1 second. You will put the value, you will get the answer. Okay, one problem. Second very standard problem I am just telling you, it's a, suppose there is one ball is there, suppose 1 kg I am taking it, it is coming like this, and after striking it is going like this. And I am just taking very simple case, very simple case. Okay, suppose this angle is equal to 30 degree and it is also returning at the 30, or you can better, I will take it 37 degree or 37 I can put it, 37 degree, and this speed was v equal to suppose 20 meter per second, and it's also moving with the 20 meter per second, no problem. Now question is that what is the change in momentum, and the time of contact, again I am taking it, t is equal to 0.1 second. So delta t is equal to 0.1 second, that I am discussing it. So very first thing, what is the change in momentum? So change in momentum means final momentum minus initial momentum. So what is the final momentum that we have to write? So just please understand the things that you have to take the component. This angle is 37 degree. So this would be 20 into cos 37. This is 20 into sin 37. Okay, sin 37 means actually 3 by 5. So if you multiply, that would be 12 meter per second. It would be how much? 4 by 5, that would be 16 meter per second. Here also you can take the two component, that would be 37 only. So this would be how much beta? 16 meter per second. It would be 12 meter per second. So if you write v initial, I am telling you this direction, I am taking, this is the x-axis, this is y-axis beta. So v initial is equal to initial velocity, if I am talking about, that would be 12 I cap minus 16 j cap meter per second. If I say final velocity, that would be how much? 12 I cap plus 16 j cap. Okay, that is the final. If I say change in momentum would be beta m into v final minus v initial. So just subtract it. Mass is already given to you 1 kg. Final is this minus initial. If you subtract it, so this would be only I cancelled, j will be added, that would be 32 j cap. Okay, this is change in momentum. Directly you can write it. Okay, or that is the meter per second, definitely the total become 32 kg meter per second in J cap. If I write the force would be delta P by just wait 1 minute, that would be 32 divided by 0.1, that would be 320 Newton. That's the very basic question, we can discuss it. Okay, just give me 1 minute. Okay, so this was the question that we are talking about the change in momentum. Everyone getting this thing? Please reply. Please reply, beta. Your understanding? This point is clear or not clear? Please reply on it. Give your reactions. If you are understanding, that would be good. Okay. Good. Ramesh. Other people also please reply and tell me your understanding. Now variable mass problem we are going to start. That is a very simple thing. Variable mass. So mass is varying. I am just giving a very standard problem. Suppose it's a conveyor belt is there and it is rotating, it is moving with the like this, belt is moving with the constant speed v. Just like if you go in a airport or in a railway station, okay. So in a mall, so what is happening when the entry gate is there? So they put one conveyor belt for scanning our articles. So we are putting our bag on the conveyor belt. It is moving from one place to another place. That we call conveyor belt. It is moving with the constant speed. Suppose. So we say constant speed, and on this I am just putting some sand, okay, or some matter or mass that at a rate of dm by dt. The very first thing, what are the extra force required to move this conveyor belt with the constant speed? So F is equal to dm by dt into V. Very standard, very simple question that we are talking about it. Okay, first question. Second question I am just discussing about it. If you see it, that I am talking about the rocket problem. So rocket is there. Suppose this is rocket, beta. So in rocket, flue gases are coming out. Okay, flue gases are coming out. Suppose this is speed is Vr and its mass is m. So this fuel is burning at a rate of dm by dt. Fuel is burning at a rate of dm by dt, and this flue gas is coming at a rate of Vr. So what is happening? This is a flue gas is going downward. So due to that, there are Newton's third law, the upward force would be there, that we are putting it upward force, that we call it dm by dt into Vr. dm by dt into Vr, we are putting it. So from that we can write that the force, upthrust force, that is equal to dm by dt into Vr. So very few basic question comes to you here. I am just discussing few questions. What should be the minimum Vr should be there so that it can sustain the mass. So sustain the mass means this is equal to mg, we can put it for sustaining. So just equate upthrust is equal to mg. Sometimes they ask it, okay, what would be the upward acceleration? That means upthrust force is bigger than the mg. Then you can say F upthrust minus mg is equal to ma. So from here also I can say A is equal to F upthrust divided by m minus g. So these are few basic type of problem that comes in the paper, we can discuss related to this problem. Now third problem related to the variable mass problem is that we call it Hodge pipe problem. Hodge pipe problem is there, beta. So I am saying it is a Hodge pipe problem. Okay, Hodge pipe problem is there. So in a Hodge pipe problem, what is that, beta? There is a pipe is there, and in this pipe it very simple thing. The liquid is flowing like this. Okay, this area is A and density is O, and the liquid is coming with the speed of V. So very simple question comes to you, but what is the force is here, beta, to hold it. So directly you will say that is equal to dm by dt into V. Okay, dm by dt into V I am putting it. What is dm by dt? Directly you can say either this is one method to write like this. The second method you can say dm by dt can be density into volume. Volume means area into length, means that is equal to also dm by dt into v square. Okay, I am repeating again, try to understand it. If you are not understanding, listen carefully. That would be d over dt, that would be density into volume. Volume is area into length. Suppose I am taking length is x. This is a dm by dt into v, you can put it. So from here what you will get? You will get very simple thing, that force is equal to beta rho into a dx by dt, that is the velocity, and outside is also velocity, that is the v square. We can write like this, is also equally correct. Now third way to write the same force is equal to what beta? Try to listen. This dm by dt into v, this can be written in another format also, like this. Okay, I am multiplying here beta dx by dx. So if you take dx this side and dt this side, actually we call in the mathematics, this will be called actually what? Chain rule. So chain rule I am just applying here. So what you will get? You will get it dm by dx into v, and this is dx by dt. This is again velocity. So this become f is equal to dm by dx into v square. That you have to learn it. This is instantaneous force, we are applying it. Instantaneous, but that particular instant you are applying it. If you take average, you have to put the half, okay, about you have to multiply half in every place. You will get it, the average value. That is a very simple thing that we are putting it, force. Come to the point. This is a variable mass problem. Now we are coming to the tension. Now what is the tension? Tension is what beta? Tension is one electromagnetic force. What force beta? Electromagnetic force. So electromagnetic force, it is a pulling force. So because force are two types, either it's a pull or push force is there. So when I am taking a pull force, that means whenever I am taking one string or rope or wire, okay, or rod, I am connecting and I am just pulling somebody, that we call it pulling force. So I am suppose this is I am having a pen and I am just pulling it like this. So this is a tension, it will come into this wire, okay, in this rod. What will come? Tension will come. So tension is generally we are discussing in the wire or rope or string, okay, this type of thing that we call it tension. This is electromagnetic force. So it does not depend on the gravitation force, that should be clear to you. I will just discuss few questions first, you will understand it. Suppose one body is there and I am just taking mass m and I am just pulling with the tension T, okay. So what is the acceleration? That question is there. So directly you will say you are pulling it that tension T is equal to m into a. So a is equal to T by m, very basic question. Now I am putting is suppose two bodies. This is the first example. Second example, there are two bodies are there beta. There are two bodies are there. The body 1 and body 2. If you are saying this is a m1 and this mass is m2, and I am putting the numerical value also, that would be more clear to you. This is suppose 2 kg and this is suppose 6 kg, and you are here applying suppose 40 Newton force. The question is that what is the tension here beta? What is the tension? So you have to first understand that this both body will move together. They are not going to move separately. So they are moving together. That means the 40 Newton is pulling both of them. That means 6 plus 2, that means 6 plus 2 both is moving with some acceleration a. That means 40 is equal to 8 into a. That means a is equal to 5 meter per second square. Very basic question that we are going to discuss. Now using this concept we can calculate the tension. So how to calculate tension? You can make FBD of any one of them. Suppose you are making FBD of 6 kg beta. It's a 6 kg, that would be tension. So you are just pulling it and the acceleration already you know that is 6 meter per second square. So tension is equal to what beta? M into A, because no other force is acting here in a horizontal direction. So you will say 6 into 6, that would be 36 Newton. That's the answer. Now any other student can also say you can make the video of 2 kg, can we get the same answer? So I am just discussing, yes, you will get the same answer. It's a 40 Newton and you are putting one tension here. Definitely it is moving in a forward direction. You will understand it. Oh sorry, I have made a little mistake. The acceleration was 5, so you have to take 5. Just wait. 5, this was a 5, that would be 30 Newton. Sorry, please correct it. Okay. Now it was moving in this section, that is equal to the acceleration of 5 meter per second. So from here we have to calculate. Yes, we can calculate it. Definitely you will say the horizontal direction, the net force is in the right direction, that means 40 minus tension is equal to m into a, that means 2 into 5. So that would be 40 minus t, that is equal to 10, that means t is equal to 30 Newton. So that is you can calculate either this way or this way, that doesn't matter, you will get the same answers. Okay, so I think it is more clear to you. Now I will just give you one more example that would be, I think, more appropriate. Try to understand it. Suppose I am putting it this 2 blocks or 3 blocks, you can take it, and this whole system is moving. You are pulling with some force. I am giving you this values 2 kg, 4 kg, and this is a 6 kg block. Okay, so I am just putting it that is equal to 150 Newton. 150 Newton I am just pulling upward. So 150 Newton I am just taking it. Now what will happen, beta? You have to calculate this T1, this you have to calculate T2. You have to do it. So, and what is the acceleration upward, that or downward, whatever it is, you have to calculate. So this type of question coming to you. Harshita, beta, I am discussing the same thing. Okay. Another thing, Pulley problem I am coming after. Just this I will rethink. Just don't worry about it. Just be in the class. Okay. I will discuss. So this is the one thing that we have to understand. So we have to calculate. So whenever this question comes to you, first you have to see the downward net, downward force. So from here that would be 6g, 4g, then 2g, total become 12g. So 12g means 120 Newton. At the 120 Newton, this is 150 Newton. So net force is upward direction only. So you will say for 50 minus 120, and this all particles were moving together. That means 6 plus 4 plus 2, that is 12 into A. So that would be 30 is equal to 12A. A is equal to 30 by 12. That would be 6. That would be 5 by 2 meter per second square. That's a very simple thing. Acceleration. You can calculate it. No problem. If you know acceleration, you can calculate the tension also. So better to calculate from the lower side first. From this, then this, you will get the answer. Suppose this is a 6 kg block. You are making FBD. This is a T2. It is going upward. Acceleration you know, but downward force is only 6g. So you will say T2 minus 60 is equal to 6 into A. A you already know, put the value, you will get the answer. Okay, I am just solving for you, you will understand, you can check it. What is that value, beta? T2 into 60 plus 6 into 5 by 2. From 2 this become 3, 15, 60, that means 75 Newton. That is equal to T2. So T2 you can calculate. Similarly, you can do for T1 also. So if you are making this T1, suppose you are making a FBD of 4 kg. So if you say 4 kg, upward force is T1, downward force is T2, one more force is 4g, but it is moving upward with the acceleration A. Okay, so definitely upward forces would be more. So you will put it, okay, sir, T1 minus 40 minus T2, T2 would be 75 is equal to 4 into A means 5 by 2, you can put it. So from here this becomes 2, so this becomes T1 is equal to 115 plus 10, total become 125, what Newton, you can check it. So just check and you can tell it what are the answers. So T1, T2 you can calculate. Very basic type of problem comes to you. Okay, now another question comes to you related to the pulley type of problem. Harshita, beta, please focus now. And other people also, you can check what I am telling you. Suppose there is a one pulley there. It is a pulley. On this pulley there are two blocks are there, beta. I am just connecting it. It is the 2 blocks. Okay, this is the M2, this is beta M1. I am putting it. This is M2 and M1 is there. And what is happening? The M2 is going downward and M1 is going upward. So if you say this acceleration is A, this acceleration is A, I have to calculate this acceleration. So this tension is T. So definitely you will say that the downward force is M2G beta, and upward force is the tension here. Here also tension T, and this force is M1G. Now try to see if I am saying M2G is going, M2G is bigger as compared to the M1G. That means M2 will go downward and M1 will go upward. It's a very simple thing. Okay, no problem. So in this situation that we have to calculate what is the acceleration, what is the tension, what is the acceleration and what is the tension is there. So try to focus it, try to focus that you can do it. You will say, sir, m2g downward, okay, minus m1g is equal to m1 plus m2, both are moving together with the acceleration a. So from here what this become, m2 minus m1 into g divided by m1 plus m2, that is equal to a. We can put it, we can understand it. It's the very basic thing that we call it acceleration. What we call it? Acceleration. Okay. Now from here I can calculate the tension also. Definitely I can put the tension. What is tension? Tension is equal to, if I want to write, so any one FBD you can make it. Suppose you are making FBD of m1, so that would be tension. Downward force would be m1g. It is going upward direction with the acceleration a. So you will say, so T minus m1g is equal to m1 into a. A value we already done. If you put it, you will get answer 2 m1 m2, okay, divided by m1 plus m2 into g. That's a very, very simple and standard result that we are going to use it. Understood? This is the connected type problem. I will give you one more example, you will understand. Okay. Suppose there is a one table is there and you are putting one pulley here, and this mass is beta here, that is the m1, and one mass is hanging, that we call it m2. Now question is, what is the acceleration here? So again you will say it is going downward, it is going in horizontal direction. So mass is m2g, but in this direction only one force is tension, and this is also tension. So very simple, the moving force is, that means actually driving force in this situation is only m2g. m2g is equal to m1 plus m2 into beta a. So from here what is the a? A is equal to m2g divided by m1 plus m2. That is the simple answer that we can talk about it. If I ask you again tension, definitely you can calculate the tension. What is the value of tension beta? So tension is equal to m1 into a. m1 we already know, and a also we have calculated, m2 by m1 plus m2 into g. What this value is equal to? T equal to m1 m2 divided by m1 plus m2 into g. That we have to put it, you will have to keep this answer. Understood? This is a very basic type of connected body problem that comes to you. Now I will discuss one more force that we call it normal force. I think it is clear to you. Please give your reactions on the chat box, please. That will help me to understand how the things is going on. Next is a normal beta, normal reaction. When I am saying normal, it's the reaction, one of the normal reaction part is there, and it acts perpendicular to the surface, and it's electromagnetic nature, and definitely it's the push force, not pulling force. It's the push force is there. So what is the meaning? It's the push force. It's the act perpendicular to the surface, and that normal thing, it is independent of the gravitation force. Now basic question I am just telling you, you will understand. Suppose there are two blocks are there. I am putting this block, this is the m1 and this is the m2. So we have to calculate normal. So I am just telling you here beta, this force would be here normal n1 and this normal would be n2. That I have to calculate n1 and n2. So how to calculate? Very simple. You will see the m1 downward force is m1g, upward force is n1. It is going anywhere? No, it is not going anywhere. Just all forces should be balanced. That means normal is equal to m1 into g. Very, very basic thing that you have to learn it, understand it. Come to next point, that is equal to m2. What is this force beta? Downward m2g. Okay, upward force is what beta? n2. Downward force is what beta? n1. These are the forces acting on this body. So what is that value beta? n2 is equal to n1 plus m2g. n1 we already calculated, that means n2 is equal to m1g plus m2g. That we are putting it, we have to understand it, that the very basic thing, that is what is the n1, what is the n2, we can put it, we can calculate. Okay. Now come to the inclined plane, you will understand now more clearly. Suppose the inclined plane is there, and on this inclined plane this angle is theta. I am putting one block, that mass is m. This mass is m. I want to calculate what is the normal force. So you will put that is equal to normal force is there. One is 4 pi mg. If you take the component, that would be 2 component along the block, along the inclined plane and perpendicular to the inclined plane. This angle is theta, this would be theta, that would be mg cos theta, and it would be mg sin theta. So definitely you can say normal is equal to mg cos theta. Okay, and downward side is about mg sin theta, so we can put it. So directly what you will say, mg sin theta is providing you acceleration that is equal to m into a. So what is the acceleration? Acceleration is equal to g sin theta. That's the basic question that comes to you. I'll give you one more question related to this inclined plane is there, beta, and on this inclined plane I'm just putting this angle is theta. Okay, this is inclined plane and this angle is theta, and I'm putting one block here. This is m1. There's a one pulley and I'm just hanging one part that is equal to m2. Now what will happen? Try to see. So that would be downward. It is suppose going. It is going upward. So what are the forces acting on it? So you will say directly that would be m2g, and this side force would be m1g sin theta. You will put it. So what is the net force? So this force is downward is the m2g minus m1g actually sin theta is equal to m1 plus m2 into a, because both are moving together. You can put it this value. So from here you can get the answer. What is that value, beta? Please tell me. The a is equal to m2 minus m1 sin theta into g divided by m1 plus m2. That's the very basic thing that we can put it. So this type of basic question, connected type of question comes to you. I will discuss one more thing, that with a normal reaction type question. Suppose there are two blocks are there. This is a 10 kg block. Suppose this is a 20 kg block. Okay, and I am applying from here. There is a 50 Newton force, and I am applying from this side that is equal to 20 Newton force. So question is very simple. Calculate the acceleration of the system, and second is the what is the normal force acting between them. What is the normal force acting between them? But please everyone, my request, please put some reaction. You are understanding, or I am just putting the things on the board only. Okay, so please understand. So put some reactions. Harshita, Pavan, Ramesh, Nikhil. Okay, the other people also, whoever in the class, please put some reactions. Okay, please understand. So if you see this 50 Newton is acting rightward direction and 20 Newton leftward direction, the net force would be how much, beta? That is the 30 in right side only. So directly you will say the net force is equal to 50 minus 20, that is equal to 30, but both is moving together, that means 30 into a. You can say the 30 is equal to 30 into a, that means a is equal to 1 meter per second square. It's a very, very simple thing that we are talking about it. Now come to the second case. What is the normal force? The normal force, any block you can take it. Suppose you are taking this is 20 kg only. It's a 20 kg. This side force is 20 Newton, and this side force is normal force. Suppose I am saying this is N1. N1 force is there. So, but this block is moving right side with the speed of with the acceleration of 1 meter per second square, beta. That means N1 would be greater than 20. So you will say N1 minus 20 is equal to 20 into A. That means 20 into 1 actually. So N1 is equal to 40 Newton. That's the very simple thing that you have to understand it. Clear or not clear? That we can discuss, we can understand it. What are the normal reactions? What are the formal connected bodies? What are the tension? I think it is clear to everyone. Yes or no, sir? Please put the some reaction on the chat box. Okay. Now come to the next point. I am discussing one more thing, that is the actually friction force. When I am talking about the friction force, when I am putting friction force, what is the meaning of friction force? So just give me 1 minute, I will take some water. Hello. Now, but come to the point. The friction force, very important topic, and you have to understand it because it's a little difficult as compared to the other forces what we have studied. Friction force. When we are talking about the friction force, we have to understand very clearly what is the meaning of friction force and where it acts, what are the types of friction force that we are discussing. Very first thing is that in friction force that we are discussing, it's the very first thing, it is the actually reaction is a one component of the reaction force which act along the surface, parallel to the surface. It acts parallel to the surface, not perpendicular. Perpendicular, the component we call normal. Parallel component we call friction. Okay, one thing. Second thing, it is also electromagnetic, just like normal. Okay. Third thing, it is a surface force, correct. Contact force, correct. Normal is also contact force. Without contact, there is no normal. Next thing, if we are talking about the friction force, what is the meaning of friction force? What it wants actually? It opposes the actually motion or it opposes the relative motion? The answer is that it opposes the relative motion. It does not oppose the motion. Actually, I can walk, the train is moving or car is moving on the road. Okay, bicycle is moving. Okay, any animal can walk on the road. These are only due to the friction. If there is no friction, definitely we will slip, and if we say movement, that is a two different thing. If I am walking or I am running, it is only due to the friction is there. If between my feet and floor is there no friction, so it is very difficult. So friction helps us to walk, it helps us to run, helps us to move for any engine also. So that is a very important component of our life. But this is also having some problem also that we call wear, tear and effect. That means due to this engines or our shoes or our slippers are actually after some time having wear, tear effect, then we have to throw them. Okay, after some time. So this is one negative part of friction also, but it's a good part, good force in our nature. Without that, many things will be disturbed. Now come to the next part. In friction, we define as three types of friction. First, we call it static friction, that we call it limiting friction, and third, we call it kinetic friction. Other than we can define some more friction like rolling friction. So rolling friction is not required right now, but the rolling friction value is very small value as compared to the other three friction what we have discussed. So rolling friction, because it acts on a rolling body, with circular body, if it is rolling on any surface, flat surface. So we assume it is a solid. Solid means completely solid, there is no deformation will occur. But in real life, what happens whenever any body is, suppose car tire is there, so when it is moving on a road, so it deforms little bit. It is actually deformed. The deform means it is not contact with the road at one point. It is more than one point. The surface is there. So this force is little more as compared to the rolling friction. But still, it is very less as compared to the other frictions like static friction or kinetic friction. Now try to come to the next point. When we talk about the static friction is there, kinetic friction is there, or limiting friction is there. Limiting friction is nothing else, it's actually maximum value of the static friction. When we talk about the static friction means the friction force acting on a body when body is at rest. Body is at rest. That means body is not in motion. Body is not in motion. Body is at rest. But it want to move. It want to move. Okay. So it want to move when it is, we are saying that we call limiting friction. Just to move we call limiting friction. But body is at rest when you are applying some force, that we call it static friction. Okay. When body is in motion, we call it kinetic friction. So what is the differences? I will just tell you one by one. So if I say that the one static, it is a static friction. So if I say static friction, at that point of time you have to understand it is equal to the F external. Okay, just a negative sign, opposite action. Okay, if you put it. And body at rest. Second is what beta? F limiting value. When I am talking about limiting friction, that is equal to what beta? That is equal to mu s into n. Okay, it's very simple. Body is still here at rest, but just to move. okay, or about to move. The third case we are talking about, that is equal to here that kinetic friction, that value equal to mu k into n, that I am talking about. N is the normal actually. So body is in motion here. Body is in motion. Here body is in motion. So when body is in motion, we are using this. So these are three different things that we are going to discuss. Okay, try to understand. I will give you some examples. So example 1, I am taking it very simple. Suppose you are putting one block here. Okay, this is a 10 kg block, and if I put it mu equal to 0.2. So my first question is, what is the friction force acting here? Can anyone reply? What is the answer? Can anyone reply what is the answer would be this? So 10 kg, this is mu equal to 0.2. If you want to calculate normal would be 10 into g. I am just helping you. That would be how much beta? 10 into 10, that would be 100 Newton. Okay, normal force. So using that part, if you want to calculate the friction force, friction is equal to mu into n. You will say 0.2 into 100, total become 20 Newton. Correct, incorrect? Please reply. Okay, definitely it is incorrect. It is an incorrect value. So what is the friction force? Friction force is equal to 0, because this body is at rest. A body is at rest, that means it does not want to move. There is no external force, so it is not going to move. It is not going to move, so definitely the friction force is equal to 0. Now try to come to next point. If I say the same force I am putting here, there is a 10 kg and I am putting here suppose a 15 Newton force. So now question is that what is the friction force? Mu equal to 0.2 only. Now we have to calculate. So what is the value will come? So directly you will say that 10 kg it's the 15 Newton. So mu equal to 0.2 you are saying. Mu equal to 0.2. So we have just now calculated the mu equal to 0.2, that means static friction, limiting friction, that is equal to how much? 20 Newton. But I am applying only 15. That means this is less than the limiting. That means it will not going to move. Not going to move means body is still at rest. Body is at rest. Body is at rest still, that means friction force we have to apply, that is equal to static friction, and that is equal to actually negative of the external force. That's why we call it the self-adjusting. It adjusts its value and direction both. So directly it will be minus 15 Newton. Minus means opposite direction. That's the simple. We can discuss it. One more question I am just discussing that you can say directly. It's a 10 kg and I am saying suppose it's a 25 Newton force. That's the mu equal to 0.2. Now you can tell it what is the answer. Okay. So what will be the value? Directly you will say from here. What is body at rest or motion? So body here will move. Why? Because limiting friction we have calculated that is equal to 20 Newton. But I am applying now 25. So definitely it is going to move it. When it is going to move it, that means body is in motion. Okay. Motion is there. So definitely there would be some acceleration is possible here. So what is the downward backward direction friction? Backward direction friction would be kinetic friction actually. So you will say kinetic friction is equal to the same value because mu value same. So mu into n you will put it, that means 0.2 into 10 into 10, that is equal to 20 Newton only. Forward direction 25, backward direction 20. So what you will say 25 minus 20 is equal to 10 into a. So you will say 5 divided by 10 is equal to a. That means that is equal to 0.5 meter per second square. It's a very basic thing that you have to understand it. Okay. So that's we are going to discuss, that is a friction force, how to calculate. I'll give you some more examples, you will understand it. Check. Suppose this inclined plane is there, that is a mass I am placing on this inclined plane, that mass is m, and it is a one to slide down. It want to slide down here. If you see it is sliding, I am just telling you sliding down. But already I am telling you it is sliding down. That means there will be two things. One downward force is mg sin theta, and upward force would be mu mg cos theta. Mu mg cos theta. Downward force is the mg sin theta, mu mg cos theta, sliding down. So very simple thing, what is the force is bigger, that's the simple mg sin theta is bigger. So you will say mg sin theta minus mu mg cos theta is equal to m into A. A is equal to g sin theta minus mu g cos theta. That we have to understand it. Okay. Now try to understand it. What is the acceleration? So this type of question comes to you that we can discuss. One more thing I am just telling you. Suppose there is one block is there. This mass is m. It is moving on a rough surface. Okay. It is moving on a rough surface. The very first question comes to you. What can be due to this friction? What can be the maximum acceleration? Or you can understand. Suppose I am saying there is one man is there. The man, one athlete is there. It want to actually run on this ground, and this value is mu between his shoes and ground, that is equal to mu value. The question is what can be the maximum acceleration of this athlete? Can you tell me? The very simple thing, the acceleration is equal to, because the only friction, due to friction it is able to move, so friction is equal to m into A, because there is no external force other than friction acting here. So directly you will say friction can be possible mu into n. So you will write mu into n, that means mu into m into A, that is equal to mu into mg. We can put it. M is cancelled, that means A can be mu g. That can be the maximum value of. Okay. So whatever the mu value is there, and just multiply with g, you will get the answer. That is equal to acceleration is equal to mu g. That's it. Okay. Okay. Aparna, good afternoon, beta. Okay. Now we are discussing this friction force. So friction type of question comes to you. So I think everyone can understand what is the meaning of this. Now come to the next point. I am taking now the pseudo force is there. So when we are talking about the pseudo force it act in a non-inertial frame. So what is the non-inertial frame that you have to understand? Okay, not too much question comes on that, but we can understand basics of pseudo force. So there are two types of forces are there. That first we call it what, beta? Inertial frame. Inertial frame is the frame in which the Newton's laws, first, second laws, okay, they are valid. Okay, they are valid. If they are valid in the first, second laws are there, then we call it what, beta? That the inertial frame. And generally these frames are at rest, and they are in a uniform motion or in uniform motion with respect to the laboratory frame. So they are at either at rest or they are in a uniform motion, then we call it, it's inertial. But remember, Earth is not inertial frame. We solve complete thing with respect to Earth, but they are not. It is not an inertial frame. Why? Because Earth is having a rotation. So due to rotation, it is having some acceleration also. It is having acceleration. So due to acceleration, what is happening? The things are going to that is a non-inertial frame, because non-inertial frame means the frame which is having some acceleration, Okay, Pavan, what is the problem, beta? Please tell me. Please explain. I want to think. What is the problem? Okay, you can put the chat. Okay, I am just telling you one thing. When non-inertial frame, that means that the accelerated frame. Accelerated frame means there will be some acceleration. Suppose truck is moving with some acceleration, then a non-inertial frame. In that we have to apply pseudo force. In what is the magnitude of pseudo force? Pseudo force is equal to mass of body and acceleration of the frame, and it is in opposite direction, that we call it a pseudo force. I'll just give you one example. Okay, so try to listen carefully first. Suppose there is one truck is there. Okay, it is moving in a forward direction. Okay, like this. This is a truck. It is moving with some acceleration A, and there is one block is there that passes m. Okay, and mu value is given to you here, and here to here, suppose distance I am just telling you. Okay, this is a 4 meter. Okay, this is a 4 meter distance is there. I'm just okay, ignore you, just I'm the basic thing I'm just telling you. The very first question is that okay, what should be the maximum value of A so that this block is not going to slide? What can be the maximum value of A that this block is not going to slide? That we have to understand. So you will say that the block is there, So there can be the backward direction, opposite direction, there would be pseudo force, that means ma, because this frame is a inert accelerated frame, the non-inertial frame. And in this case the friction force, we have to apply this direction, that friction force is equal to mu into m into g. You just equate it, so you will say ma is equal to mu mg, that means a can be maximum value, that is equal to mu g. That means up to here you can apply, no problem. If you are applying more than it, definitely it is going to slide backward direction. Okay. Please Pavan, tell me what is the problem. Like motion in a straight line. Explain new chapter. Like motion in straight line. Live too long. I understand that part. I am also working beta. Okay. You are just watching it become too long for you. I am continuously working. So try to understand. Appreciate those things. Appreciate the efforts. Okay. So now come to this very simple thing. So this is pseudo force. I am not taking this too much in detail, but okay. Now come to the next point that we are discussing. That next topic is there. Very first work, energy and power we can discuss.